Most modern JavaScript developers have probably heard of React before. React can be said as the most well-known JavaScript libraries or frameworks that help us to build UI. Now the big question is, what makes React so special that it became one of the front-end giants today? Now to answer this question, let's spend a bit of time talking about the values that React brings to the table. Now suppose we have an H1 in our DOM, and we want to update the content of it using JavaScript. In vanilla JavaScript, the traditional way of doing this is to first target the element and then manipulate the attribute of the element in JavaScript. This is what I call a DOM-driven approach. In other words, the content manipulation revolves around the DOM. Although there's nothing wrong with this approach, however, sometimes it could feel quite cumbersome, as we always need to target the element before we can perform an update. This could be quite distracting since we always need to properly manage our element IDs and also the associated targets. Now React took an entirely new approach in regards to DOM manipulations. Rather than focusing on the DOM, React focuses on the data, which I call the data-driven approach. That means we'll shift our focus onto the data rather than the DOM. I can't really do any demonstration on React at this stage because there are quite a bit of setup work needed to be done before that. So I need you to use your imagination here for a bit. Now, here's how the concept works. If we want to change the content of our heading here, instead of targeting the heading element, we would bind a variable directly into the DOM. So we will create a variable in JavaScript and use some sort of syntax inside our HTML to load the variable in. And when we want to update the DOM, we simply just need to change the variable itself. Isn't that neat? The actual React code is not that far off from what we have here. Can you see the benefit of using a data-driven approach? You can see that we're abstracting away the low-level logic and focus on what is really important, which is the data. And that concept is one of the biggest values that React brings to us. Other than the data-driven approach, React also provides us another revolutionary concept called the virtual DOM. The virtual DOM is basically the powerhouse for data binding in React. You see, behind the scene, React needs some sort of mechanism to efficiently update the DOM in order for data binding to work. The thing is, manipulating the DOM directly could prove to be slow and expensive. The notion of virtual DOM is to clone the whole DOM structure into the memory. So, when we want to apply changes inside the DOM, we simply need to update the virtual DOM instead of the real DOM. Since the virtual DOM is living inside the memory, it is super quick to update it. And once we are happy with all the changes, the virtual DOM will then apply the changes efficiently in the real DOM by comparing itself against the structure inside the real DOM. This process of syncing the node structure is called reconciliation in React. Anyway, virtual DOM is the technology that makes DOM updates in React super efficient and fast. That way we can build a very fluid and smooth UI experience without putting a lot of burden onto the browser. Alright, this is a quick intro to React, and hopefully now you understand why using React is quicker and a more logical choice to build UI in our web applications. We'll learn more about React in the next video. Alright, key takeaways for this lesson. React is a JavaScript library to build user interface. React is data-driven rather than DOM-driven, which means it abstracts away a lot of the low-level API and lets us focus on what's important. In other words, the business logic. The virtual DOM is a clone of the real DOM, which enables React to quickly and efficiently apply changes in the UI. That's it for now, and I'll see you again in the next video. React is a modern library, and that means when we write our app in React, we are making use of the modern features like ES6 module systems, promises, and other awesome features in JavaScript. We're also able to utilize the packages registered on npm. And that means we can leverage on the open source packages created by some other developers to speed up our app development process. However, there are a few implications here that we need to consider. Number one, we need to find a way to load all the files from our project to the browser. and also including all the npm packages that we have installed for the project. This is not a big problem for modern browsers that supports ES6 features. However, it will be a massive problem for Stone Age browsers like Internet Explorer. Seriously guys, make the world a better place by stop using Internet Explorer. Anyway, to add all the modules and dependencies into our browser, we'll need to carry out an operation called bundling. Bundling simply means that to combine all the files in our project into fewer files and load these files into the browser. This process is very similar to bundling items in real life, except that we're bundling files rather than items in our web app. Now to bundle files, we need a bundler. There are a lot of bundlers out there in the wild, and I would say the most popular ones at the time of recording this video are Webpack, Vite, and Rollup. The official bundler of React is Webpack, but in this tutorial series, I'm going to use Vite because I like Vite better. I'll show you how to set up a React project using Vite later, but for now, let's discuss the next problem, where the modern features of JavaScript are not supported in all the browsers, like the bloody Internet Explorer. To address this issue, modern bundler will typically perform something called transpilation on our code. Transpiling simply means that to convert our modern JavaScript codebase into something that's compatible with Internet Explorer, so our code can run in that abomination. You also probably will hear about the word polyfilling, which simply means adding the necessary code to our codebase so that a certain modern feature will work in an older browser. For example, if we want to use promises in Internet Explorer 6, we need to polyfill first before our code can work in that thing. Now, the question is, what would be the typical way to do transpilation? Fret not, the JavaScript community got our back. There is an amazing JavaScript transcompiler called Babel that will do all the hard work for us, and it can be integrated seamlessly into Webpack or Vite. Now typically, if you're setting it from scratch, you might want to do a few configurations, which could be quite scary for beginners. But fortunately, if you're starting a React app in the official way, all these configurations have already abstracted away from you. So you don't really need to touch anything, and you're gonna have a working bundler and Babel ready to go. Alright, so that's a high-level explanation on a bundler and transcompiler. Let's go to our code now and look at how we can set up a brand new React project using Vite. Vite actually provides us an easy way to scaffold a fresh React project. We'll go to our terminal and type in npm create vite add latest and our project name at the end. This command will magically execute a script to create the necessary files and folders for us to start a brand new React project. Once the command is completed, let's cd into our project directory and type in npm install to install all the dependencies. Once that's done, let's open our project folder in VS Code. And now as you can see here, we've got quite a few scary things going on here. Let's go through the files together one by one, and hopefully you're no longer shitting your pants after that. Alright, first and foremost, we have vite config.js here. This is where we define all the configurations for Vite to build and bundle our app. And as you can see here in the file, Vite has provided us a plugin called React that extracted away most of the configuration logic into the React plugin, so that we don't need to sweat the details. You can put in a lot of other configuration options here inside the define config function if you want to customize the behavior of Vite. Feel free to consult documentation for that. But for most cases, we don't need to touch a single thing inside this file. Next, let's go to our package.json. And here, as you can see, we've got a very clean package.json as our starting point. Vite does provide us a few handy scripts which we can use for development and production purposes. The dev script is the main command that we'll be using in our development. It will start a hot reload server that will listen to all the changes that we have in our project and magically update the DOM for us. You'll see how it works later. The build script is where we tell Vite to build our app. So Vite will compile all the assets in our project into files that are optimized for production. We only need this command when we are ready to deploy our app. Now the preview script will start a web server in your local machine for you to preview your production build. Everyone that's connected to the same Wi-Fi will have access to this web server. It is a quick and easy way for you to share your website with your friends and family. Next, let's take a look at the index.html. This is the main entry point of our website. It is just a simple HTML that contains one div with an ID of root and also a script tag linked to the main JSX file inside our source folder. So the idea is simple. The JavaScript inside the main JSX file will build and mount the React app into this div with the ID of root. And now at this point, you might be wondering, what the hell is JSX? Why don't we use JS file? You see, the notion of JSX is a special kind of syntax that allows us to write HTML-like code in JavaScript. The X in JSX stands for XML, which means it is a mix of JavaScript code and XML. And XML is a superset of HTML, and that means we can write our own custom HTML tag in React. If you're confused at this point, don't worry, I promise it will be clearer later on. The takeaway here is that if you name your file as JSX, VS Code can offer a better auto-completion and syntax highlighting to you. Alright, now let's take a look at the main JSX file. And as you can see here, it's a normal JavaScript file, but with a twist. There are two things that I need you to take note of. First of all, we are seeing custom XML tags inside our JavaScript code. So the XML tags from line 7 until 9 are exactly what I was talking about earlier. This is JSX, the mixing of JavaScript code and XML tags. And you can see that we are importing a custom HTML element on line 3 and use it on line 8. Now the second thing that I need you to take note of is that on line 4, we are importing a CSS file. This is not possible on vanilla JavaScript. However, since we are using a bundler like Vid, it is now possible for us to import all the assets files including CSS and images into our JavaScript code. Importing a CSS file has the same meaning of loading a CSS inside the head tag in our HTML. So the benefit of importing CSS file in our JavaScript is that we can keep our HTML file very clean and write modular code. Later on in the series, I'll show you all the best practices for us to write a maintainable and modular code base. Now the last thing that I want you to take note on is that on line 6, we are simply calling the create root function from the React DOM module. By reading this code, I bet you can kind of understand what's going on here. So this line of code is essentially telling React to use the element with the ID of root as the base or the root of the entire app. And then we'll go ahead and call the render function to mount whatever we pass in into the argument of the render function into the React root. Don't worry about the strict mode custom element for now, and we'll go straight into the app custom element. We'll talk more about the strict mode later on in the series. Anyway, you can control click or command click if you're on Mac into the app custom element, and VS Code will bring us straight to the file. And here we see quite a lot of scary things again. Don't shit your pants just yet. Do it after we have completed the lesson. So what's going on here? This file contains only one function, which is the app function, and we are exporting the function out as a default export. This function is something what we code as a React component. Don't worry about the details and implementation in this component just yet. We'll zoom out a bit and look at the big picture. So this function is simply returning us a lot of HTML code, and this HTML code is the content of this component. So that means when we load the app component in the main JSX file, what React will do behind the scene is to replace the app custom HTML tag with whatever HTML we have returned in our app component. We can create as many components as we like in a React project and load them one within the other. So that means I could write another custom component and load it inside our app component, and the process goes on. So the main thing here that I need you to understand is that when you're writing an app in React, you should really think in terms of components. You could write components called round button, cards, heading, and so on and so forth. Anyway, we'll talk more about them in the upcoming videos. For now, let's try to run our app. We'll go to our terminal and run npm run dev to trigger the development script. And you should see this default page showing up in the browser. If not, that means you have f***ed up somewhere. And I want to show you one last thing before we end the lesson. Remember the hot reload server that I was talking about just now? Let me demonstrate it to you now. As soon as I make some changes in our source code, we can see the changes applied to the DOM almost immediately without me refreshing the browser page. And this is the voodoo magic of hot module reload, HMR for short. Alright, key takeaways for this lesson. Bundler like Webpack or Vite compiles or bundle our project files, and they'll take care of file imports and optimization, so we don't need to sweat the details. Babel transpile and polyfill our codebase so our app can be compatible in all the browser like Internet Explorer. JSX syntax allows us to write XML in JavaScript code. Hot module reload or HMR magically updates the browser on file changes. React is a great library, so don't shit your pants. That's it for now, and I'll see you again in the next video. You see, I have a problem. Whenever I'm doing my routine workout, I always needed a timer that will alternate between my rest time and my workout set time. And also, I have another issue where I constantly need to remind myself to stand up from my work desk, because you know how developers can sit on the same chair for the whole day without seeing the sunlight. That is super unhealthy, so I figured I need to fix this. So I came up with an idea of creating an interval timer using React that could solve both of my issues, and hopefully it'll help you as well. So this is how it looks like. So in the main page here, we have a simple UI where we can define the timer for our interval, where the app will run the timer in consecutive order. We can click on the plus button to add a new timer, and we can also click on the delete button to delete a timer. We can edit the timer title and also the duration in each timer. And down here we have an option to toggle between looping indefinitely or a one-off timer set. If we enable the loop, that means our app will repeatedly run these two timers indefinitely. Alright, why don't we click on the start button and see how the app works. And now we're in a new page where we can see a countdown timer with a progress bar, which shows the progress of the timer. We also got a heading here that shows what is coming up next after the current timer has expired. On top of that, every time when the current timer is expired, the app will play an alarm to notify us. I have turned off the sound because it gets super annoying when it is played repeatedly. But you can see here on the browser tab title, this tab is indeed playing some sort of sound. And I can also click on the pause button and the countdown will stop. And when I click on the play button again, the timer resumes. And if I click on the stop button, we get a prompt to tell us to go back to the main menu. And we can start the process all over again. And that's it. That's a quick demo on the app that we're gonna build in this series. Although it looks simple, there's actually a lot of moving parts happening behind the scene. There'll be a lot of things to go through, and I'll teach you step by step on everything that you need to know in order to become a decent React developer. And just a heads up, I assume you're fairly good with JavaScript and understood most of the ES6 syntaxes. You also need a bit of knowledge on Node and also how to use npm. If you have no idea on what am I talking about now, I'll suggest you to take a look at my other JavaScript series before jumping onto this series. The link is in the description. I can't wait to show you how to write this app, so I'll see you in the next video. Let's get rid of the starter code for a fresh start. The first thing that I want to show you is to see how it can load a JavaScript variable onto the DOM, which is sometimes called as data binding. It is very simple. Let's create a variable called ABC. And let's say I have an h1 here in this component. If I want to load the variable ABC into the h1, we simply need to put a curly braces and chuck in the variable name. That's it. The syntax is exactly that simple. So in React, whenever you want to run JavaScript code inside the DOM, we simply need to surround our JavaScript code with curly braces. Alright, let's run our app. We'll go to our terminal and type in npm run dev. And now in the browser, we see a heading with the value of our variable ABC. Isn't that neat? With JSX, React makes it super simple for us to combine JavaScript code and HTML. And since we're using JSX, we could also store a HTML element in a JavaScript variable. I'll show you what I mean. Let's create a new variable called paragraph. And the value of it is a p tag and with ABC as its content. And now I'll load the paragraph variable directly underneath our h1. And there we go. It works. And again, just to emphasize this, JSX makes it possible for us to define HTML element as a variable. How cool is this? And imagine what you can do with this feature. This is extremely powerful and we'll be definitely using it later on in the series. Next, I want to introduce you to the concept of reactive variables and state. A reactive variable is a special kind of variable that will update the DOM whenever it is changed. Let me show you an example to illustrate this. Let's consider this scenario. I'm going to change my ABC variable into a let variable, and then I'm going to call a setTimeout function to change ABC into 456 after 2 seconds. Now what do you think will happen after 2 seconds inside the DOM? Currently in our HTML, we are binding the variable ABC to the h1 and the p tag. Since after 2 seconds, the value of ABC will change, would I still see 1 to 3 or do I see 4, 5, 6? Think about it for a few seconds. Some of you would think that we will see 4, 5, 6, right? Well, let's find out. I'll show you the browser again, and we see 1, 2, 3. 2 seconds has long passed, and we still see 1 to 3 in the DOM. If you don't believe me, I'll call a console log in a setTimeout function to prove that it is indeed running. And I'm gonna go ahead and refresh the page. Let's wait for 2 seconds, and we see setTimeout printed out in the console while the DOM remains the same. So what the hell is happening here? Why isn't the DOM updated to the latest ABC value? Well, the answer is because ABC is not a reactive variable. It is just a plain and normal JavaScript variable. In other words, if we update a normal JavaScript variable, it will not update or re-render the DOM and therefore will not see our changes inside the DOM. So what's the solution for this? The answer is simple. We just need to create a reactive variable for ABC instead of a normal JavaScript variable. Let me show you how to create a reactive variable now. To do that, we need to use the useState function provided by React. Just remember to import it from the React library. UseState is one of the many so-called hook functions provided by React. A hook is defined as a function that will be triggered whenever an event happens. Let's look at how we can use the useState function before we elaborate more on the topic of hook function. So essentially, the useState functions allow us to create a reactive variable. It will accept one argument, which is the initial value of our reactive variable, and it will return us an array that contains 2 elements. I'm using array destructuring here, so the first element is our reactive variable itself, and the second element is a setter function for us to set the value of our reactive variable if we ever want to change it. And now you might be wondering, why do we need a setter function to change the reactive variable? Why can't we just change the variable itself, just like normal JavaScript? Well, the answer of this question is closely related to the nature of hook. Remember what I said just now, hook is a function that will be triggered whenever an event happens. So when we want to change the value of ABC, we want React to re-render the DOM. Calling the setABC setter function will trigger React's internal hook functions to re-render the DOM. In other words, if you just change the variable ABC itself, React's internal hooks will not be triggered, and therefore the DOM may not be re-rendered correctly. So when we talked about the React hook functions, like useState and the other ones in the future, you need to understand that these functions are used to create some sort of values or functions that will trigger React's internal hook functions, so that React can re-render the DOM. Anyway, let's see how we can change the value of ABC. So rather than changing the variable ABC directly, we need to call the setABC function and pass in the new value. And now take a look at the DOM. The latest value of ABC is now reflected in the DOM when we're using the setter function. If you don't believe me, I'll refresh the page and we get 456 after 2 seconds. Now before we end the lesson, I do want to clarify that the term state is a jargon which means data. And to simplify, you can think of state as variables that can be changed. Alright, key takeaways for this lesson. Data binding means to bind JavaScript variables into the HTML directly. Reactive variables will get React to re-render the DOM when they are updated, and JSX allow us to store HTML elements to a variable. Hooks are functions that are triggered when an event happens, and the useState function is a React hook that allow us to create reactive variables. That's it for now, and I'll see you again in the next video. React makes it super easy for us to bind event listener to an element. Now suppose we have a button inside our DOM, and when we click on this button, we want to trigger a function. For example, let's say I want to change the value of ABC when I click on this button. Let's create a function for that. I'll call it changeABC, and inside the function body, we'll simply call the setABC setter function to change the value of ABC to AAAAA. And now in order to bind this event listener to our button, we simply need to bind the function definition to the onClick attribute on the button. Now VS Code is pretty smart. You can see a whole list of auto-completion in a drop down here that corresponds to different kinds of events where we can attach to this button. We're interested to the click event, so I'll use the onClick attribute here. And now I'll simply pass in our changeABC function and it should just work. Take note on the curly braces here. Remember what I said in the previous video, whenever we want to run JavaScript inside our DOM, we got to use the curly braces. We're passing in a function definition here, and that's JavaScript code, therefore we need a pair of curly braces. Okay, now let's test our code. I'm going to comment out the set timeout that we have previously set up, and let's click on a button. And we now see 1 to 3 change to AAA. Isn't that neat? It is that simple to bind an event listener into the DOM using React. Alright, key takeaways for this lesson. We can bind an event listener directly to an element by passing the function definition using the curly braces notation. For example, to attach a click event listener, we can attach the function on the onClick attribute on the element. That's it for now, and I'll see you again in the next lesson. HTML has attributes. Similarly, React components also have a similar concept known as props, which is short for properties. Let's take a look at how that works. We'll go ahead and create a new heading component. We'll create a new folder called components, and I'll create a new file called headings.jsx inside here. And now remember what I said in a previous video, to create a React component, we have to export a function inside this file, which is something similar to our app.jsx. That means every time we want to create a new React component, we have to include all this boilerplate, which is rather tedious. As a lazy developer, this is a big no-no. What can we do instead is to go to the extension panel and search for ES7, and we will install this amazing extension that can take care of the boilerplate easily for us. So once you have installed it, let's go back to our file, and we want to create a React functional component, so we can type in RFC and hit tab. There you go. This is just pure magic. And notice that the function name is exactly the same as our file name. How cool is that? The only thing though, since React 18, we no longer need to import the React modules on every component. So you can omit line 1 if you want. Anyway, for now, let's try to load our custom heading component into our app.jsx. VS Code is quite intelligent with React component import. So to import our heading component, we simply need to use an angle bracket and type in the component name, which is heading. You can see here from the drop down, we simply need to hit tab in order for us to import the component. And upon closing the tag, VS Code will close the tag for us as well. And now if we look at the import section of the file, you can see that our heading component is imported inside this file. How cool is that? We don't need to import our component manually, and we can just let VS Code do the work for us. Anyway, let's go to the browser now. And we can see that our component is now inside the DOM. Beautiful. And now let's talk about props. It would be nice if we can customize the size of the heading just by passing in some sort of options to our heading component. So the code will look something like this. This is the concept of props. As you can see here, it looks exactly like HTML attribute. We are essentially passing in additional data into our React component. And that means we need a way for the heading component to receive the incoming data. And the answer is inside the function argument. So every React component will receive an argument which will contain all the props that was passed to this component. I'll show you what I mean. If I console log out the prop, you can see that in the browser console, we are able to see an object with one property size in it, which is exactly the data that we pass to our heading component. If I were to pass in more props to our heading component, then the prop object will grow larger and larger. Anyway, the size property should determine the size of our heading. Let's apply an inline style to our heading. In contrast to normal HTML, in React, we need to pass in an object for the inline style, just like what I am doing here. And VS Code will provide you the corresponding autocomplete to make our life easier. All the property names has to be camel case, so just be aware of that. And one more thing to take note of, you'll notice that the console log comes in pair. But we only console log out the props once only in this component. This is an intentional behavior triggered by something called the strict mode in our app. Essentially, strict mode will always render our DOM for twice with the purpose of rendering our component deterministically so we can catch any bugs early on. The idea is a component should behave the same no matter how many times you run it. So strict mode helps us to catch any bugs in case something works differently in a second render. By default, strict mode is always on, as you can see inside the main JSX file. If you want to turn off strict mode, feel free to remove the strict mode wrapper component here. Anyway, let's go back to our app.jsx, and now if we change the size of the heading into something else, you can see that in our browser, our heading grows bigger. And if you look at the component API here, with JSX, it's very intuitive and easy to work with. Some other useful props that might be worth implementing includes color and alignment. I'll leave that as an exercise for you and see if you can figure it out. Now at the moment, our heading component is pretty shit, because we're hard coding the text content of the heading. A better component design would be displaying whatever text content that we put within the component's opening and closing tags. Now we can retrieve this data from a special prop called children, as you can see here inside the console log. So the children prop of any React component refers to whatever that we have put in between the opening and closing tags. Let's refactor our heading component. So the content of the h1 should be props.children. And it works. We can really pass in any sort of data as a prop to a React component, including functions, object array, boolean, number, and etc. And now you might be asking, what's the use of passing all this data type to a component? It's a long answer, but you'll find out more as we dive deeper into this series. But for now, I can give you a short example to demonstrate how passing a function as a prop could be useful. Now suppose you want to make our custom heading component clickable. So when a user clicks on a heading, you might want to redirect them to a different website or different part of the page. So what we might want to do is to attach a click event listener to the h1 element so that it will trigger a custom prop function that will pass to this component. Let's do that. So back inside app.jsx, I'll pass in a new prop called click to the heading component and attach a custom function to it. Then we'll go to our heading component and add an onClick event listener where the value will be the click prop function that we pass to this component. So now when the heading is clicked, it will trigger the click prop function that was passed to this component, which was defined inside app.jsx. And now just for demonstration, I'm going to console log out hey ya in the say hello function and go ahead and click on heading. And now in the browser console, we can see hey ya gets printed out. And that is a simple demonstration on how a prop function can be useful. There's one last thing that I want to talk about before we end the lesson, which is something called the single root principle in React. The single root principle says that every React component should have one and only one root element. Let me demonstrate this principle to you. Let's go to our heading component. If I attempt to return two root elements, React will be super unhappy about it, as you can tell from all the errors that it is spitting out at the moment. However, sometimes there are instances where we really want to have two root elements. There is a workaround for this. It's something called the ghost template or the fragment component, which is basically an empty tag that looks something like this. The fragment tags are virtual tags that will not add any node to the DOM, and yet it will still fulfill the requirement of the single root principle. It serves as a great workaround in situations where you want to return multiple children, but didn't really want to wrap them all in a single parent. Alright, that was a quick introduction to props. It will probably take a while to wrap your head around the syntax, so take your time with that. I'll see you in the next one. Key takeaways for this lesson. Props are external data passed to a React component. You can think of props as HTML attribute, but for React components, we can pass any kind of data type as props to a React component. Props children refers to the content that we pass within the component tags. Fragments or ghost templates are virtual tags that will not actually create a node in the DOM when the components was rendered. Components need to comply with the single root principle. In other words, every component should return one and only one root element. That's it for now, and I'll see you again in the next video. Okay, let's create our application's navigation bar. We will go ahead and create a new component called navbar and load it inside app.jsx. Now typically, a navbar would contain a few links for us to navigate to different pages in our website. And traditionally, we would use an unordered list to create those links. And in normal HTML, if we have 5 items inside the navigation bar, we gotta copy and paste the li element for 5 times. Although this works, however, this is not the philosophy of React and programming in general. Copy and pasting is a big no-no in programming, especially we are just only changing the link name each time. So is there a better way to do this? Hell yeah! So in React, we gotta shift our mindset from DOM-driven to data-driven. So here, what we can do instead is to loop through an array of links and generate a list item each time. I'll show you what I mean. Let's create an array of nav items. Each item is represented by an object, which contains the title property and the href property. Now our objective here is to convert this array of objects into an array of list items. So what we can do here is to call the map function on the nav items array, and for each nav item object, we will return a li with an a tag in it. Now do take note that we're using a one-liner arrow function here. That's why we don't need a return statement. We're returning the li block in one go by wrapping it with a round bracket. If you happen to need a multi-line operation here, just remember to use the curly braces and include a return statement inside the arrow function. Anyway, now we can see that the links are generated beautifully with a few lines of code. This is a lot more maintainable compared to traditional HTML because now if we want to add or modify the existing nav items, we simply need to modify the array, rather than going through the HTML and refactor the code one by one. Isn't that neat? Now if you think that putting in the map function inside the HTML is too messy, we can always extract it out into a separate function and call it inside the DOM. Let's do that just for demonstration. I'll create a function called render nav items and move the map logic into the function. And now inside the DOM, we can simply call the functions and it will still work as before. We can also store the result of the function into a variable and load it to the DOM, and it will still behave the same way. And one last thing before we end the lesson, if we open the browser console now, we saw a warning saying that each child in a list should have a unique key prop. Although using the map function to generate elements is nice and convenient, however, there's one thing that we need to be aware of. Whenever we put an array of elements inside the DOM, React needs to be able to uniquely identify each of the elements inside the array. And to do that, we need to supply a key attribute to each of the elements. In our case here, each nav item has a unique title, so the title property will be perfect to use as a key attribute. And now if we refresh the page, the warning will no longer appear. Great! So essentially, if the key is changed, then React will re-render the corresponding element in the array. In other words, React relies on a key to decide whether to re-render the element or not. Alright, key takeaways for this lesson. We can load an array of elements into a React component and React will render them accordingly. The array function map is incredibly useful to help us generate a series of similar elements. We should set the key props to each element in the array, and React uses the key props to identify the elements and decide whether to re-render the DOM or not. That's it for this lesson, and I'll see you again in the next video. Sometimes there's a need to run some logic when a component was mounted to the DOM. For example, we might want to make an API call to get some data from the API server when the component was first mounted. A typical scenario would be in the rendering of the nav bar. In a lot of apps, we will typically have a sign-in button in the navigation bar. Now, depending on whether the user is logged in or not, we might want to display the user's avatar if the user is logged in, or the login button if the user is not logged in. In other words, when a nav bar is mounted in a DOM, we probably need to send an API request to the backend to see if the user is logged in or not. Now to run a certain logic when a component is mounted, I'm going to introduce you a new hook function called UseEffect. Let's look at how this thing works. We'll go to our navbar component. And the first thing that we want to do is to import the function. VS Code is smart enough to import it for us if we hit tab on the autocomplete. Now the UseEffect function accepts two arguments. The first argument is a callback function where we'll define the logic to run in this UseEffect. The second argument is an array of state that we want this UseEffect to watch in order to trigger the logic that we define in this UseEffect. In general, there are three forms of UseEffect. A UseEffect that does not have a second argument, a UseEffect that has an empty array as a second argument, and thirdly, a UseEffect with some sort of state inside the second argument. Let's go through them one by one, and I'll show you the differences between them. We'll start by the UseEffect in the second form where it has an empty array in the second argument. And again, the second argument defines what state would the UseEffect should listen to in order to trigger the logic. By default, all the UseEffect will be triggered when a component was mounted. By passing, an empty array says that the UseEffect is not listening to anything. Therefore, this UseEffect will only be run once, when a component was mounted. I'll print out some dummy console log inside this UseEffect just for demonstration. Let's go to our browser, and if we look inside the console, we see our text gets printed out in the browser console. It was printed out for 2 times merely because we are using React strict mode. Next, let's look at the third form of the UseEffect. In this case, the logic will be triggered whenever there's a change in our state that we put inside the second argument. Just for demonstration, we'll create 2 states. And we'll get the UseEffect to listen to one of the states. And now if we look at the browser console, the functions in both UseEffects are triggering. That's because, as I mentioned before, all the UseEffect logic will be triggered whenever the component was mounted. And now I'll attempt to modify our state counter A and see if that UseEffect will be triggered. Let's create a new button, and when we click on this button, we will increment the value of counter A. And now whenever we click on a button, we can see that the UseEffect logic is triggering, because the UseEffect is listening to changes in counter A. If we make changes to counter B, this UseEffect will not give a damn. Unless we add counter B to the watch array. Once we have added counter B, clicking on the button will start triggering the logic once again. However, subsequent click will not retrigger the logic. This is because we are setting the value of counter B to always be the same value. Counter A, which is 0 at the moment, plus 1, which will always equal to 1. Now the UseEffect will only be triggered when there's a change in the state. Since counter B is not changing, therefore it will not retrigger the logic. If we change the value to be counter B plus 1, clicking on the button now will then start triggering the logic, because every time we click on the button, the value of counter B will be changed. Now let's talk about the first form. If we don't pass in a second argument to the UseEffect, then the UseEffect will listen to all the state changes in the current component. So now when I click on the button, I am changing counter B, yet it will trigger the listen to all UseEffect. So once again, in a nutshell, if we do not pass in a second argument to UseEffect, then this UseEffect will listen to all the state changes happening inside this component. If we decide to pass in an empty array as a second argument, then this UseEffect will only be triggered for once when a component was mounted. If we do pass in some states in a second argument, then the UseEffect will only be triggered when those states are changed. It might take some time to digest this, and in the future we'll look at some practical example where UseEffect can be very useful in our application. For now, try to remember the different forms of UseEffect, and we will continue in the next lesson. Alright, key takeaways for this lesson. UseEffect is a React hook that will trigger a function whenever there is a state change. All the UseEffect hooks will be triggered once when a component was first mounted. The first argument is a callback function where we define the logic for the UseEffect. And the second argument is an array of state where we want the UseEffect to listen to. That's it for now, and I'll see you again in the next lesson. When we are using hook functions, there are some rules that we need to stick to. The first one is we should only call hooks at the top level. What that means is we can never call hooks inside an inner scope. For example, inside an if statement, a loop, or a nested function. Currently in our app.jsx, it is okay to call our useState function directly in the same scope of our app functional component. However, it's not okay to put it underneath an if statement. Similarly, you don't want to put it inside a for loop or an inner function. The reason why this rule exists is because if we put the hook function call in some other scope, there's no guarantee that this hook function will be executed and they will not be visible to React. If these hook functions are only sometimes visible to the React component, then it might cause some unexpected behavior, and our application would have a lot of bugs. Now the second rule is that we can only call hooks from React function. That means we can't execute hooks inside regular JavaScript function. Therefore, we can only call hooks from React component or from a custom hook. A custom hook is a hook function created by us. They are wrappers around the built-in hook functions, and the objective is to help us to simplify our component's logic. I promise we will talk more about custom hooks in a later episode. Now is simply not the time, because you'll probably get very confused. For now, just try to remember these rules that we have talked about in this lesson. Alright, key takeaways for this lesson. We should only run hook functions at the top level. In other words, we should never run hooks in an inner scope, for example, an if statement, for loops, or inner functions. We should only call hooks from React component functions or in the custom hooks. That's it for now, and I'll see you again in the next video. There are a few standard ways for us to apply CSS styles in our React component. Generally speaking, there are three ways. First is to use inline style. Second is to use third-party libraries that will do something what we call CSS in JS. And thirdly, which in my opinion, the best option out of these three is to use something called CSS module. And just for demonstration, we'll try to style our navbar in our app. First of all, let's look at how we can use inline style to style our component. As we mentioned before, we simply need to pass in the style attribute to the HTML element. I'll set the background color to red. And now let's go to our browser, and we see a red navbar now. Great! Inline style is nice and simple, however, it has its own shortcoming. We couldn't write media queries for inline styles. Well, to resolve this issue, you could argue that we can just simply write the media queries in a CSS file and import it inside this component. Right? Well, the answer is no. You see, when we write React component, the concept of isolation is super important. That means we should think of every component as an individual and independent unit in our app, and the CSS that we attach to a component should only be available to the component itself, without interfering with other components in our app. When we import a CSS file just like what we did here, the style sheets defined inside this CSS file will not be scoped to this component. In fact, the moment when we import a CSS file, everything will become available to our whole app. In other words, whatever I have defined inside the navbar.css file will become available to my heading component and also my app component. This is super dangerous, because there's a high chance that we might reuse our class names across multiple components. And due to the cascading nature of CSS, the CSS classes will end up merging together, and our app will end up having a lot of unexpected surprises, which is very hard to debug and maintain. And that leads us to the next question. How do we make sure that our CSS classes are scoped to a component rather than globally available? And the answer of this question is to use something called the CSS module. Now what we need to do is to rename our CSS file into a file name ending with the word .module.css. And we'll go ahead and create a new class here called nav, and we'll set the background color to red. And now back inside the navbar component, what we need to do now is to import the CSS file into a variable. Once we do that, all the classes that are listed inside the CSS file will become an object. I'll show you what I mean. If I console log out the CSS import, let's take a look at our browser console. we can see that our component is printing out an object with a key called nav, which was exactly the class name that we have defined in our CSS file. And the value of it is some sort of unique string. And this is the way on how React can help us to scope our CSS classes to a certain component. When we import a CSS module file, it will automatically assign a unique name to all the classes defined in that module file. And just a side note, it's a standard practice to always put the module CSS file in the same folder as our component file. Let's go ahead and assign our nav class to our nav component. Now, I haven't mentioned about this before, but in React, if you want to give an element a class, you have to use the class name attribute rather than the typical class attribute. This is an API design choice made by the React developer team, so we just have to get used to it. Anyway, for the value of the class name, we simply need to put class.nav. And again, I'm using a curly braces here because we're passing in a JavaScript code inside the HTML. And now the red background color is back in business. And if we inspect it inside Chrome's developer tool, we can clearly see that the class applied to the nav element is the unique class name that we get inside our console log. And that is CSS module in a nutshell. We can go ahead and write more styles inside our navbar module CSS file, and feel free to put in any media query that you see fit. It will work exactly like a normal CSS file. CSS module is great out of the box, since it provides us scope CSS and we don't need to install any third-party library, plus it is fairly simple to use. However, there are third-party solutions that help us to load CSS into our component. Those techniques are something what we call CSS in JS. If we go to Google and type in CSS in JS libraries, and you'll find a lot of resources and different kind of npm libraries for you to install in your project. Essentially, CSS in JS library allow us to write CSS style sheet within JavaScript code. One of the most popular libraries is something called styled component. And this is actually something I would recommend you if you decided to install a third-party library. So if we look at the sample snippet here, we can see that in order to apply CSS style, we'll first import the library and create a component by specifying the tag name followed by a backticks. And within the backticks, we can put in any sort of CSS properties. And the library will create a React component out from this syntax. And we can go ahead and use this style component inside the DOM. Now, the other popular library is called JSS, where the concept is quite similar to CSS module. But in my opinion, it is a bit more complicated and less intuitive than CSS module. So here's the syntax. We first need to create a JavaScript object that contains all the classes that we want to create. Within each classes, then we'll attach the corresponding CSS properties. Once we have defined the styles object, then we'll pass it into the create style sheet function, where the library will create the scoped classes for us. And we can go ahead and pass all the classes into our DOM. This might be helpful in vanilla web projects, but not so much in React, because I think CSS module is superior in every way. Anyway, just before we end the lesson, let's go ahead and style our navbar. I'll turn on my speed hack so I can code faster here. Alright, looking good. And that is about everything that you need to know on how to style your React component. Key takeaways for this lesson. If we import a CSS file directly inside a React component, it will make every style inside a CSS file globally available to other components, which is a big no-no. To create scope styles, we have a few options. One is to apply inline styles to HTML elements. Two is to use CSS module. And lastly, we can use CSS and JS libraries. That's it for now, and I'll see you again in the next video. If you're here, that means you have voluntarily chosen to be rickrolled, and there's no way that I'm gonna give you up. Anyway, the purpose of this video is to consolidate everything that we have learned so far and put it into practice. Let's go to our code and I'll create a new component. And we'll call it rickroll. we'll use a shortcut React functional component to generate the boilerplate, and in here, our objective is to create a button that will rickroll people. Upon clicking on this button, we will add a Rick Ashley GIF into the section below here. And now it's a good idea for us to extract out the button into a separate component. Let's do that. I'll create a new component called button, and it is a simple wrapper around the native button. The reason why we want to wrap a button component is because it's easier to style the button once and reuse the button across our React app. So the next time when we want to change the styling of the button across our website, we simply need to go back to this component and change it here instead of going through the whole app and refactor all the buttons, which would take forever. I'm not going to style the button for now, we'll just focus on the functionality. Anyway, I want to pass the children within the button tags and pass the rest of the props to the button element. However, at the moment, it is fairly hard for me to do that, because if I unpack all the props inside the button tag, the children prop will be passed as the button attribute as well. How do we solve this? Well, we could destructure the props argument into children and pack the rest of the props into a props variable using the triple dot operator. And now, problem solved. This little simple JavaScript techniques can really help us to write very clean code. Anyway, let's go back to our rickroll component and load our custom button inside here. And when we click on this button, we want to generate a new rickroll inside this component. Let's add a new event listener called Rick, and we'll attach it to this button. Now the main purpose of our Rick function is to create a new Rick. Ideally, we want to store all the GIF inside an array. Let's do that. We'll create a new state by using the useState React hook. And now we can use the useState snippet to generate the boilerplate for us to create a new state. I'll call the array rickroll, and it will start with a default value of an empty array. So the next task that we want to do now is to add a new GIF into our rickrolls array. Let's go to Google and search for a good one. Alright, this looks pretty annoying. Let's pick this. We'll copy the image address and we'll go back to our code. Let's create a variable and put the URL inside it. And then we'll go ahead and code a setRickroll function and add a new item into the array. So here we're saying that the rickroll state variable is an array of URLs. And now it's time to convert each of these URL into images. And as mentioned in the previous lesson, we can use the map function to achieve this. So inside the HTML, we will map each of the URL into an image element. And now our component is mostly done. Let's go back to our app.jsx and load our rickroll component. And now let's go to our app. We can see that there's a big button calling us to click on it. And with every click, we will be rewarded with a brand new Rick Ashley. Alright, that's all. Hope you had fun with this simple component, and we'll continue our React journey in the next video. I'll see you there. Being a React developer means that we're going to shift our mindset from writing UI component in traditional HTML and JavaScript into the modern way. First thing first, we need to start viewing a web page as a composition of several components. For example, let's take a look at Google's homepage. It seems like a normal homepage that we all got used to it, but there's actually a lot of things going on behind the scene here. Now, if we break down this website in terms of components, we can say that there's a navbar component that is made out of a few link component and a button component and also the avatar component. And upon clicking on the app button here, we have another sub-component displayed in a DOM that displays all the app that Google provides. Each of these apps could be another component that we load within this app button dropdown. And now zooming out in the middle of the page, we could have another component that displays the search bar. And inside this component, we have the logo component and also the search bar component, followed by two button components down here. And in the footer, we have two sections. One is the country, and the second row is some other miscellaneous link components. So once we can visualize the whole web page as a composition of UI components, the next step is to think about and plan for your next project. Wireframing is extremely important because it helps us to not only visualize the UI and UX of the final product, but also help us to plan for the data flow that happens among the components. Let me give you an example. Let's say I want to build an admin dashboard to manage the users in our app. We'll have a page that contains a search bar and also a table underneath it to display the user data. So in here, we have three major components: the page, the search bar, and also the user table. Now think about this. Which component should we store all the user data? In other words, which component here should be the one that calls the user data API to fetch all the user data for us to show in the user table? Now you might be thinking, we should put it inside the search bar, right? Because the search bar is the main component that performs the searches. Well, the answer is no. Why? Because how are we supposed to pass the data into the table? Remember, the search bar and the table are siblings. If we put the data inside the search bar component, that means we gotta pass the data to the parent, which is component A, and get A to pass to C. While I'm not saying that this is impossible, but it will involve a lot more work, which requires state management, and that's a more complex topic to be discussed later on in the series. And if your answer is to put in the user state data into the table directly, then we would have another problem. How are we supposed to get the search term from the search bar component? The same issue arises. That means we've got only one choice left, which is to put the user state data in component A. So component A will be responsible to fetch the user API and to store the user state. So one way of connecting all these components together is that we will attach a search function to the search bar, so whenever the user types something inside the search bar, we'll trigger this function, and this function will call the user API. And upon calling the user API, we'll update the local state inside component A, which then will feed this data into the user table. In industrial term, component that doesn't have any business logic inside it, like the search bar and the user table, are known as dumb component. A dumb component's behavior usually relies on a prop passed to it. For example, the user table that we have here will simply rely on the user data that we pass to it and render the data in a table. Typically speaking, a dumb component will only have props passed to it, and it usually does not contain any state. Other examples of a dumb component are your typical building block in your app. For example, a button component, a card component, a link component, heading, icon, input, form, and etc. These components should contain zero business logic and are highly reusable across our app. On the other hand, we also got something called the smart component. A smart component, or sometimes known as containers, are components that contains business logic, and they are made out of dumb component. They usually contain states, and component A here is a typical example of a smart component because it runs business logic, in other words, fetching the user API, and contains a state. Anyway, let's go back to wireframing. We could use software like Figma, Miro, or even pen or paper to build our wireframe. So once you have got your wireframe, list down all the components that you need in your app. And think about reusability. Generally speaking, if part of the UI has multiple use cases across our app, it's a good idea to extract it out into a separate component. So in short, we should break our app into the smallest possible building blocks. Now here's a question. If we are going to build all the generic components from scratch, it's going to take a massive amount of time. We will need to build our own custom button, form, input element, so on and so forth from scratch. And that is not ideal at all, especially when we have limited time and budget. So how can we make this better? The answer is, we could leverage a UI library where someone has already done the hard work for us. For example, in React, Material UI is an extremely popular component UI library that is based on material design. As you can see here in their documentation, they have provided us a whole range of beautifully designed front-end UI components that we can use in our project out of the box. They've got a very good documentation as well and provided us snippets where we can copy and paste them directly into our code. There are other UI component libraries out there as well. I have attached a link in the description. Feel free to check it out if you want. Anyway, that being said, using a framework or UI library is a good choice if you don't want to reinvent the wheel. The people who created these libraries typically use the best practices in the industry and provided us a tons of features that would take us forever to write. Alright, key takeaways for this lesson. When viewing a web page, think in terms of components. Plan and build a wireframe before you start coding. It can really help us to visualize the data flow. Dumb components are components that usually don't contain state and rely entirely on the props. They don't run business logic. Smart components, also known as containers, usually contain states and business logic. Leveraging a third-party UI library is a good idea to speed up your development process. That's it for now, and I'll see you again in the next video. Having a well-organized folder structure can really help us to go a long way in our React project. The official React documentation didn't really provide us an official guideline on how to structure our project, so we are free to use any sort of files and folders convention as we see fit. Now I'm going to show you the typical way on how I would structure my React project. First and foremost, in the src folder, I would have a components folder. This is the folder where I put in all the reusable dumb components in our app. The components that we put inside here should be generic and not specific to any particular page. At the moment, we have a navfile component with a modular CSS file. As you can tell, most components will have their own CSS file attached in the same folder. And as our application grows, it could get quite messy. So sometimes it makes more sense for us to create a separate folder just for the component. Let's do that for our navbar component. Once we have created a folder, we can put all the navbar related components inside this folder. For example, the navbar link, navbar logo, so on and so forth. Technically speaking, I wouldn't consider navbar as a reusable component. A navbar is really part of our application's layout, so it's not so appropriate to put the navbar component inside the components folder. We'll move it out later. And the same for the rickroll component that we created in the previous episode. These components are rather specific, so it makes sense for us to create another folder for them. I will consider them as smart components, and typically I'll create a new folder called containers where I put in all the smart components in here. Now, as I mentioned just now, the rickroll component deserves to be inside this folder. We'll move it across to this folder now. Containers are really components that are designed specifically for a page, and we rarely need to reuse them. And the next folder that I would create is called pages. This is where I define the pages in my app. And the name of the components here are closely related to the URL in our app. For example, we might want to create a home page and also a contact page, and when we visit /home, our app will simply render the home component, and similarly, when the user visits /contact, our app should render the contact component. Oops, seems like I put a pages folder in the wrong directory. Let's move it out. Okay, the next thing I would have is the layout folder. Layouts, in short, are the wrapper around everything that we want to include in every single pages in our app. In a typical app, we would have 3 different layouts: the app layout, the public layout, and the admin layout. App layout is the layout where the user would see after they have logged into the app, and a public layout is the layout where the user will see as a public visitor. The public layout will fit for pages like the login page, the sign-up page, and the landing page. The admin layout is for internal use and typically would be drastically different to the app layout. Anyway, in each of these folders, we should create a layout wrapper component where we define what should be in each of these layouts. The navbar that we created in the previous episode belongs to the public layout, so we'll move it inside the public folder. And now let's create our public layout component. In the public layout, we should have a few things here: the navbar, the main content body, and also a footer. For the navbar, we can simply import our navbar component. And for the body, we can simply load props.children. We don't have a footer yet, so I will leave this section empty. And once we're done with the layout, we should wrap all the pages that we intend to use inside the public layout with our layout component. That includes the contact page and also the home page. Okay, let's move on. We can also create a new folder called utils, which is mainly for utilities in our app. Typically, I'll put in all the helper functions that I need inside this folder. For example, authentication helpers or date helpers, which help us to format the date inside our application and other miscellaneous things like that. And sometimes we would have a bigger operation or a certain module that we don't really know where to put them at. For example, the logic to calculate the geolocation or a custom library that compresses images on the front end. In that case, I'll create a new folder called services, and the services folder will contain a lot of other subfolders where each of them represent a module that we can use across our app. By definition, the utilities folder and the services folder are fairly similar. In general, services are bigger than utilities. Alright, now let's zoom out for a bit and take a look at our current folder structure. The relationship between pages, containers, and components are like our human body. Components are very similar to body cells, and containers are like organs, and pages are like systems. So a group of components will form a container, and a group of containers will form a page. The services and utilities folder are places where we put in additional logic so our React component can be less cluttered. I hope that gives you a better idea on how to structure your next React project. Alright, key takeaways for this lesson. Components are like body cells. They are generic and can be used across the whole app. Containers are like organs, they are specific to a page, and pages are like body system where they're composed of multiple containers. A typical app has 3 layouts: the public, app, and admin layout. We should wrap a page in different layout depending on the use cases. That's it for now, and I'll see you again in the next video. When we are building a React app, it would be nice if we can visualize our state and the props that are passed to a certain component. Now the good news is we have already got something like this in the ecosystem. It is a Chrome extension called React Developer Tool. Let me show you how to install it. Let's go to the Chrome extension page, and from the left sidebar, click on the Web Store button, and once we are in the Web Store, search for React Developer Tools. Let's go ahead and install the extension. And now, let's go back to our app, refresh the page, and open the Developer Tools. And you'll notice that there are 2 new tabs appeared in the menu bar. The Component tab will be the main area where we spend most of our time tinkering with our component. And you can see it from here. Currently, we're selecting our app component. On the right hand side, React Developer Tools is showing us all the props state that are contained inside this component. And if I click on the Click Me button, the state update is happening in real time. And I can also edit the state value inside the React Developer Tool, and the changes will be reflected in the DOM immediately. How good is that? We can click on different components to investigate the local state on each component. There are also other features here. Feel free to play around with them to see what you can do with the React Developer Tool. Now the Profiler tab will help us to profile our component. In other words, to measure the speed or the performance of our components. To use the profiler, we first need to click on the Record button and click on the Refresh button here to re-render the DOM, and then we'll click on Stop Recording to see the result. And here you can see that the Profiler tool is giving us a graph of the rendering speed on each of our components. This tool is extremely useful for us to find out the bottleneck in our app. So if a component has an extraordinary rendering time, that means something's up and we might need to investigate further. The Profiler is an extremely useful tool, but probably not being used so much in smaller applications or when we have very few components. However, it is still nice for us to play around with it and understand how it works. Anyway, that's a brief introduction on how React Developer Tool works, and we'll continue in the next lesson. I'll see you there. When we are writing React components, it is very common that we'll use helper CSS classes across our app. These helper classes include spacing helpers like styling the margin and padding, or flex helpers for us to easily configure flexbox, typography helper for us to style the font, color helper, so on and so forth. Although it's possible for us to write our own CSS helper classes, however, it is simply not practical in a lot of projects. Why? Because writing CSS classes from scratch requires a lot of time and effort, and in a lot of times, we're not using the industry's best practices. In other words, we are reinventing the wheels and we're making a shabby wheel. If you have used CSS libraries like Bootstrap, Bulma, or Windy CSS before, you appreciate how easy it is to write UI components. Now, among all the CSS libraries out there in the wild, I'm choosing Windy CSS for this project. If you have used Tailwind CSS before, Windy CSS will feel just like home. The reason why I choose Windy CSS is because it is blazingly fast, contains almost every convenient helper classes that you can imagine, generates CSS file on demand, and that means it will only pack in the actual CSS classes that we are using in our final CSS, rather than loading the whole library from the very beginning. On top of that, it has seamless integration of Vite and also has an amazing VS Code extension. I didn't really want to use a component-based library like Bootstrap or Bulma or Material UI because they can be hard to customize. Windy CSS offers a much more flexible API and it's very good if you want a highly customized web page. Anyway, let's go to the documentation and learn how we can install Windy CSS in our project. Let's go to the installation section and we'll click on Vite. If you're using the other build tool, feel free to choose the corresponding option. Next, let's copy the npm install command into our terminal to install the required dependencies. Once we're done, we need to set up our vite-config.js to load the Windy CSS plugin. Just copy and paste the configuration as defined in the installations page. The last step will be loading the virtual Windy CSS file in our app. We'll copy the import and paste it inside our main JSX file. And that's it. Windy CSS and Vite will take care of the rest for us. They will only include the CSS classes that we actually use in our code. So the final CSS file that we're going to bundle into the production build is actually very lean and optimized. Now the next step is for us to install the extension for VS Code so we can get Windy CSS classes auto-completion. Simply go to the extension tab and search for Windy CSS and install the Windy CSS IntelliSense VS Code extension. Once you have got that, you should now have superpowers. Let's give it a go. We'll go to our app.jsx and give our heading a background color of red. You can see here in the autocomplete, we can see a nice list of Windy CSS classes. Let's run our app and see if that works. And there you go. You should see something like this. So try to play around with Windy CSS and we'll continue in the next lesson. Key takeaways for this lesson. Windy CSS is a utility-based CSS library. It contains a bunch of helper classes for us to use across our app. Windy CSS will generate the production CSS bundle on demand. In other words, it will only include the CSS that we actually use in our code. That's it for now, and I'll see you again in the next lesson. A single-page application is a type of a modern web application where the user only needs to load the web page for once. In other words, the user will only need to download all the static assets, for example, the CSS and JavaScript files for only one time, and rely on client-side routing to navigate around the web app. By client-side routing, which simply means a mechanism to swap the content in a DOM with another without refreshing the page. We are really changing what is to show and what's not to show in a page, and hence the name single page application. Thankfully, we didn't need to do much work for client-side routing because React provided us a library called the React Router, which will do all the hard work for us. Let's see how we can install and use React Router in our project. First of all, we'll go to the documentation and head to the quick start guide. And if we look at the sample code, it is fairly simple for us to set up React Router. At the time of recording this video, the latest version is version 6, so be mindful of the syntax if you're using a different version. Anyway, if we look at a code snippet here, the first thing that we want to do is to wrap everything within a browser router component. This component will initialize React Router and allow us to use the routing logic in its children. Next, we have the routes component, and that is where we're going to define all the routes in our app within it. It looks a bit scary now, it's okay, we'll go through it together one by one. Let's first install React Router in our project. I'll copy the npm install command and paste it inside our terminal. Once that's done, we'll go to our app.jsx and initialize the React router structure as we have seen inside the documentation. We will have the browser router, followed by the routes component, and I'll also clear out all the dummy elements that we have created previously. Now within the routes tag is where we will define our client-side routes. Generally speaking, all the components that we created inside the pages folder will need to have a route. At the moment, we have a contact page and a home page. Let's create a route for the home page. To do that, within the routes tag, we will load a route component from React Router and pass in our home page component into the elements prop. Now you'll notice that the autocomplete doesn't work. This is a quirk of VS Code, so if you want VS Code to auto-import a React component for you, we'll need to pass in the props argument inside the component function, which currently does not exist inside the home component. And now back to app.js, we can see that the autocomplete triggers will now show our homepage component, and we'll hit tab to auto-import the component. Once we have specified the element for the route, we need to define the password. So in order for us to visit the home page, the user will need to visit the root route, which is a simple slash for the path props. And while we're here, let's quickly create another route for our contact page as well. Once we're done, let's go to the browser. We are at the root route at the moment, so the home page is rendering. However, if I change the URI to /contact, we get a different component rendered in a DOM. Beautiful. And that is the basic of registering client-side routes in React Router. One important note here is that we should not put any other component than the route component within the routes tag. Otherwise, React Router will complain. We'll continue in the next lesson. Alright, key takeaways for this lesson. Single page application, or SPA for short, is a type of modern web app where we need to download the static assets for only once. SPA utilizes client-side routing for page navigation, and React Router is a client-side routing library for React applications. In order to register routes in our application, we need to use the browser router, routes, and route components from the React Router library. That's it for now, and I'll see you again in the next video. Building a single-page applications means that we can't use a tag to do our in-app navigation, because the moment when we click on an a tag, the whole page will refresh, and that defeats the purpose of a single-page application. So React Router has provided us a drop-in replacement for the a tag, and it is something called the link component. Let me show you how it works. We'll learn how to use the link component by building our application's navigation bar. So let's go to our navbar component. At the moment, we're rendering the navbar item using a function called render nav items. And the function is based on the variable nav items to generate the list. Now the function is simply returning a list item element followed by an a tag. As we discussed, we should not use the a tag in a React app. What we should do instead is to import the link component provided by React Router. Let's go ahead and do that. The link component works very similarly to an a tag. But instead of using the href attribute, we have to pass in the two props to specify the link destination. And that's it. Let's edit our nav item array so that each link item can point to the correct URL. I would also like to change the href property so it makes more sense. Alright, let's see how it looks like in the browser. Our navbar still looks exactly the same as before. However, this time, when I click on a link, our page does not refresh. How good is that? And that is the essence of a single page application. We will keep looking at some other features of React Router in the next few videos. I'll see you there. Key takeaways for this lesson. We shouldn't use anchor tags in a single page application, because clicking on an anchor tag will cause the whole page to refresh, and that defeats the purpose of a single page application. What we can do instead is to use the link component provided by React Router to replace the anchor tags. That's it for now, and I'll see you again in the next video. There are instances where we want to do a programmatic navigation. In other words, using JavaScript to navigate the user to a different page without the user clicking on a link. This is particularly useful when we want to restrict access for a certain page in our app. For example, if the user tried to access the admin area, we might want to kick the user out, or if the user tried to visit the app dashboard without logging in, we might want to redirect the user to the login page. In these kinds of scenarios, we'll need to use JavaScript to run a check and redirect the user to the appropriate page. And now, let's see how this thing works in React Router. Let's create a new dummy admin page and I'll show you how it works. I'll create a new folder in our pages directory and I'll call it admin. And in there, I'll create a new file. Then we'll go ahead and add a new route in our app.jsx. Now back inside our dashboard file, this is in our admin area and we don't want our average user to come here and party. Typically speaking, we'll use a UseEffect to run a check when a component was mounted. And the check will determine whether the user is an admin or not. If not, then we'll kick the user out. We don't have any authentication mechanism here, so we'll just hardcode the check. I'll just assume everyone who visited this page is not an admin. And now, time for the main redirection logic. It's actually quite simple and straightforward. First of all, we need to call a hook function provided by React Router, and the hook function is called useNavigate. The hook function will return us a navigate function where we can use it to navigate the user around our app. So once we got the navigate function, we simply need to call it inside our if statement. So if the user is not an admin, we'll simply redirect the user to the root. Alright, let's test our code now. And just for testing purposes, I'll go to our navbar and add a new link that will send the user to our admin dashboard. Alright, let's go to our browser and see if this is working. Now when I try to click on the admin button in our navbar, the app will simply redirect me to the home page. And that means our redirection logic is working. Let's try to remove the check for now and see the admin page is rendered properly. Okay, so now when I click on the admin button, we can see our dashboard page. Great! Now typically, we would wrap our admin dashboard inside an admin layout and we'll put this admin check logic inside the admin layout, since it is required by almost all of the admin components. Alright, that was a quick intro to the useNavigate hook function. Key takeaways for this lesson: the useNavigate hook function allows us to programmatically redirect the user. It will return us a navigate function where we can use it whenever we want to redirect the user in our code. That's it for now, and I'll see you again in the next lesson. As we are building our application, it is unavoidable that we would have routes that has the same prefix. For example, let's say we have a few admin routes: admin dashboard, admin manage, and admin settings. Now all of these routes has the same prefix called admin. However, if we write our route component just like what I did here, it is not that pretty, because we're essentially repeating ourselves. So how can we improve this situation then? React Router has a solution for us, and it is called route grouping. Rather than declaring the routes one by one, what we can do instead is to have a parent route component where we define the admin path prefix on it, and within the route component, we'll define the individual children routes. One important point here to note is that we could not put a slash in front of our route path, because a slash means an absolute path in React Router. If we put a slash in front of the path, that means when a user visits the slash dashboard endpoint, we would like to serve the user the dashboard component. And that defeats the purpose of route grouping altogether. Anyway, let's visit our browser now to make sure that everything is working correctly. So if we visit the admin dashboard, we can see that the dashboard component is rendered properly. If I go to the manage endpoint and the settings endpoint, they're all working fine. Beautiful. Alright, let's move on. Now there's always a situation where we need a dynamic route. For example, an admin page where we can manage a specific user. So the routes will look something like this: /manage /users /the user ID. So if we put 1 as the user ID, we will be seeing the details of user 1 on this management page, so on and so forth. Now the question is, how do we implement this in React Router? It is actually pretty simple. Let's duplicate the manage route component, and what we need to do to make the route dynamic is to use a colon and a parameter name to represent the dynamic parameter. Once we have done that, let's go to the browser and test this one out. We will visit the admin manage user endpoint, followed by any random URL parameter. And we're greeted by the dashboard component. Great! But now we got a new problem. How do we retrieve the dynamic URL parameter? To do that, we'll need to use a hook called useParam. Let me show you how it works. Let's go to our dashboard component. And I'll import the hook useParam from the React Router DOM library. The hook will return us an object that represents all the URL parameters in the current React route. Now I'll go ahead and console log out this param object, and let's see what will happen inside the browser. We'll go to the console, and as you can see here, it is the object that contains the user ID URL parameter. The value is whatever we put inside the URL, and the key refers to the name of the parameter that we registered inside the React route component. And now we can go ahead and use this parameter however we wish inside the component. For example, let's add the value of the parameter after our dashboard heading. And now if we go back to the browser, whatever we put in the URL parameter will show up directly after the word dashboard inside our DOM. How cool is that? And if we try to visit a route that does not have a URL parameter, the param object will simply be an empty object. Alright, that was a brief introduction to route grouping and dynamic route in React. We will continue in the next lesson. Key takeaways for this lesson: we can put additional route components within another to group multiple routes together. We define dynamic routes by using the colon syntax. UseParam is a hook that allows us to retrieve the dynamic route parameters. That's it for now, and I'll see you again in the next lesson. The Windows object in the browser has a module called location that allows us to get information about the current route. Although we can use the location module to get the current route's information, however, the React Router library does provide us a hook function that can replace the location module in a Windows object. In general, if we're using the useLocation hook, we can get more information about the current route in comparison to use the location module in a Windows object. Let me show you how the useLocation hook works. We'll go to our public layout component and import the useLocation hook from the React Router library. And just for demonstration, I'll console log out the result of the hook and see what information is available to us. And now as you can see here, the location object contains a few properties. The hash and key properties are used internally by React Router, and we don't need to worry about them for now. Essentially, they are the unique identifier for each route that we registered inside the React Router. Path name represents the URI that we're currently visiting, and search is the query parameter in our URL. Let me show you how these two properties work. If I visit a contact page, notice that how the path name property has changed to /contact. And if we manually add a query parameter to our current URL, let's see what would the search property change to. The search property would just be everything after the question mark in our URL. Now the state property is one of the most important properties in this location object. This is the main way where we can pass information across different pages in our React project. Let's look at an example. We will go to our home page component and let's create a button that will redirect us to the contact page. Now for us to utilize the state property inside the location object, we'll need to use the navigate hook to perform the redirection. So in the button event listener, I'll go ahead and call the navigate function, but this time I'll pass in a second argument. Now the second argument is an object that could contain two properties. The first property is the replace property, and the second property is a state property. The replace option is a boolean, and if we set it to true, then this navigation will replace the latest route in the redirection history stack. In other words, if we set replace to true, that means when we click the back page button in our browser, the browser will be unable to return us to the previous page. Now the state property will allow us to put in any arbitrary data that we would like to pass to the next page. In this case, I'll simply pass in a dummy object. And let's see what will happen in a location object now. Let's go back to the home page in our browser, and I'll go ahead and click on a button and take a good look at the location object that we were printing out in the browser console. We now got a state property, and it is exactly the state that we pass inside the navigate function. We have just successfully passed a data from the home page to the contact page. And now you might be wondering, how could this be useful to us? Let's consider this scenario. Suppose we have an admin page that allows us to manage all the users. Now we would have a page that lists all of the current users that are using our app. Each of the table row represents a user record, and each of them would have a button that allows us to go to the edit page and edit the corresponding user's profile. Now logically speaking, we will need to call an API to get all the user information when we are at the first page. Upon clicking on a row, we somehow have to display the user information on the edit page. Now the question is, do we really need to call another API to grab the information of this specific user? The argument is that we've got the user data already in the listing page. Why don't we just pass the user information to the edit page? That way we can make one less API call to the server. And to achieve this, we can totally pass the user data to the user details page using the state property in React Router. So when we are visiting the edit page, the page will load directly without calling an API, and this will greatly improve the user experience in using the app. Alright, we'll continue to talk more about React Router in the next lesson. Key takeaways for this lesson: the useLocation hook provides us an alternative way to retrieve URL information in contrast to using the location module in a window object. We can pass data to another page by utilizing the state property in navigation. We can do that by passing in another argument in the navigate hook function. That's it for now, and I will see you again in the next lesson. The way that we define routes in React Router might look a little bit odd to some people, since we're using XML tags to define these routes. The syntax might look a little bit strange, and to some people, it's not that comfortable. If you're that person, well, I've got some good news for you. React Router actually provided us a hook for us to define the routes in the form of a JavaScript object. Now let's take a look at the syntax. First of all, we'll need to import the UseRoutes hook. The hook function will receive an array of routes object, and each object is basically the equivalent of the route component. Whatever props that we can pass to the route component, we can do the same in the route object counterpart here. So let's try to replicate our current route structure into the UseRoutes hook. First of all, we have the root route where I'll set a path to the root and the element to the home component. Next, we have the contact page, and I'll do the same as the home page component. So far, so good. Next, to replicate the admin route group, we'll need to use the children property. The children property is basically another array of routes, and each object would have the exact same structure as what we already have so far. Alright, now we're done. Let's test our code. I'll comment out the XML syntax and replace it with the routes JavaScript variable created by the hook. Okay, let's go to the browser and see what will happen. Whoops, we're greeted by a lot of errors. It says that the UseRoutes hook function can only be used inside a router component. This is an easy fix. We simply need to refactor the browser router component from our app.jsx into the main.jsx file by wrapping it around our app component. And now let's go back to our browser, and our app is now rendered properly once again. And clicking on the link in the navbar will redirect us to a different page, just like before. And that means the UseRoute hook function is working properly as a substitute of the XML syntax. And that's it. You can use whichever syntax that you prefer. Either way, they'll work just fine. Alright, key takeaways for this lesson. UseRoutes is a hook function that allows us to define routes in JavaScript object syntax in contrast to the XML syntax. We can only call UseRoutes within the browser router component, otherwise React will complain and refuse to render the page. That's it for now, and I'll see you again in the next lesson. When we visit a URL in an app, we are actually sending a GET request to a known endpoint in the server, and the server will send us the corresponding page. Now React Router is a client-side routing service, and that means the server wouldn't have known about the route registered in the React Router. So that means if we try to send a GET request with a route defined inside the React Router to the server is likely to send us back a 404 response because the route was registered inside the client side, not the server side. This could be a problem if we do not have control over the server-side code. For example, if we want to deploy our app on a static site hosting provider like GitHub Pages or Netlify, then our app should not work. So how do we solve this problem then? The answer is to use something called hash router, which is an alternative router provided by the React Router library. Let me show you how it works. Let's go to our code. We will go to our main JSX file, and currently, as you can see, we're using the browser router. If we want to change it to the hash router, we simply need to change the import to hash router instead of the browser router, and load hash router inside the render function. Let's go to the browser and take a look at the behavior of the hash router. So currently we are in the home page, and if I click on the contact link in the navbar, notice what is happening inside the URL bar. Instead of having a full URL, we have a hash sign in between the primary domain and the contact URI. And that is exactly the difference between a browser router and a hash router. The URI that you're seeing now is actually a fake URI that was not loaded from the server side, but instead from the client side. And to clarify the concept once again, we are sending a request to the backend server by the root endpoint. Once the server sends us back the React application, then React Router will take it from there by looking at what's after the hash sign and render the page accordingly. That way, the server does not need to know about the contact endpoint because it was handled by the React Router on the client side. And hence, in theory, our React app should work in any static hosting provider. And there you have it. That was a brief introduction to hash router in React. In general, I would not suggest you to use the hash router unless it is necessary. If you can use the browser router, then by all means, use it. Only use the hash router when there's no other workarounds. And if you're wondering why is the browser router working in our local development environment, it is because the Vite development server is handling all the routing logic for us behind the scene. It is acting as a web server for our React app. There are also other routers that we can use in our React project, like the memory router or static router. However, they are a bit more advanced, so maybe we'll talk about them in a future episode. Alright, we'll continue in the next lesson. Key takeaways for this lesson. Hash router is an alternative router to use when we can't register routes in a web server for some reason. React Router will render the page based on a hash portion in the URL if we are using the hash router. That's it for now, and I'll see you again in the next video. I'm sure that you have been to some websites where you visit a new page where the majority of the layout is the same as the previous page, but only a small part of the page is different. For example, let's say we are in a management page in an admin dashboard of an app. The left-hand side here is a sidebar where we can navigate to a different page in our admin area, and in the middle of the page we have the management page title, followed by a section with multiple tabs. And upon visiting each tab, they will contain a different settings and configuration respectively. Now the content of each tab is fundamentally different to each other. However, each of these tabs should have their own URL, and the overall layout of this management page should still be the same. In other words, we would like to keep the appearance of this page consistent. And the question is, how do we solve this problem? And now you might be thinking, why don't we use layout? Well, you see, the admin area could have a lot of pages, and each page could have their own appearance and layout. The main layout of the admin area should only be used for things like the sidebar and the navigation bar. Layout is not exactly useful for the internal page content. So how can we solve this? Our solution here should be something like a secondary layout that is localized to a certain page. And thankfully, React Router does provide us this feature, and it is something called outlet. Let's see how this thing works. First of all, let's create a new folder called settings, and inside here, I'm going to create a new page called settings index, which will be the main page for all the settings. And inside this component, it is where we are going to put the tabs. Let's create a simple layout for now. I'll go ahead and create a list that contains 3 links that will navigate the user to the other settings page. And underneath the links is where we want to show the different content of each page. To show the content of each page, we will need to import a new component from the React Router library, which is called the outlet component. And now I'll go ahead and create the other setting pages. And also register the routes inside our app.jsx. Once we're done, let's go to our browser and test it out. Let's go to the admin settings URL, and let's see what will happen if I click on any of the link inside the list. Since they're all using the same layout, the only thing that's changing for each page is the content section, which is exactly what we wanted. Alright, so outlet is basically a secondary layout that is useful in a localized context. It is a very handy tool that can help us tremendously, especially when our route is deeply nested. Alright, key takeaways for this lesson. Outlet is a special component provided by React Router for us to load child component. The notion is like layout, but localized to part of the app. That's it for now, and I'll see you again in the next video. React Router introduced a new API to define routes since version 6.4. It is known as the so-called Data API. Let's see what's the big deal about it. The main goal of this Data API is to make routing a lot more flexible and modular, so we can use it comfortably across our React app. There's a few changes in the new API. First of all, let's refactor our code. We'll go to our main JSX file and refactor on how we registered the browser router. Here's how it works. In the Data API, we'll need to call the create browser router function to create the browser router. The argument will accept an array of route objects, and they are the same as what we have already defined inside our app.js in the UseRoutes hook. So we can simply cut and paste it over to our main JSX file. So once we have created our router, the next step will be registering this router. What we need to do is to call a new component called router provider and pass our router variable in as a prop. And that's it, we're done. So technically speaking, we don't really need our app.jsx component, since we're now defining our routes inside the main JSX file. Let's go ahead and delete the app component, and also import all the page components inside our main JSX file. And now let's go to the browser and take a look at our app. And as you can see, everything is still working as before. Now the Data API is not just a change in the API on how we load the router. It also provided us a number of powerful features that can help us tremendously in building our front-end SPA. The most notable features are the action and loader functions that we can attach to a route. Let's look at the documentation to look at the syntax. So loader is essentially a function that will be triggered before the page is mounted. It could be useful for us to call API requests that will fetch data required by the page. Action, on the other hand, will be triggered whenever there's a non-get HTTP request calling upon the page. This function will typically be triggered whenever there's a form submission. Anyway, that was a quick introduction. We will discuss more about the details in the next lesson. I'll see you there. Key takeaways for this lesson. Data API is an alternative syntax for us to define and register the routes in React Router. Data API offers a more flexible and modular API. The loader function is called when a page is mounted, and the action function is triggered when there's a non-get HTTP request that was called against the page. That's it for now, and I'll see you again in the next video. We mentioned in a previous video that the loader in the Data API is a way for us to trigger a function when a page is mounted. Let's see how this thing works. First of all, I'm going to create a new page called user details. And we'll use this endpoint to demonstrate the use of the loader. Now the loader is simply a new property inside the route object. It is a function that takes in one argument, which is an object. And inside the argument, there are two things. The first one is the URL parameter, which in our case, the parameter will be the only one and only user ID that we have inside the path property. and the second one is the instance of the HTTP request called against the current endpoint. At this point, some of you might be thinking, hold on, what is this HTTP request presenting anyway?
Wait a minute.
Let's step back for a moment and think about this. Imagine we're using a traditional web application where we are using server-side routing. Now, if we want to visit this URL, we have to physically click on a link, and the link will send a request to the server, and the server will send us back the HTML page. Now, this request argument is meant to be the request sent to the server. However, in our current situation, since we're building an SPA, there's no need for us to send a request to the server, but the loader function will capture the request for us anyway, just in case if we need it. Let's console log out both the parameter and the request, and we'll see them for ourselves. Let's go to our browser. If I visit the manage user URL, then we can see inside our console, we have a parameter and a request. The parameter has user ID set to 1, which is exactly the same as our URL, and for the request object, it is a GET request with the URL the same as our current URL in the browser. Alright, these are just the information that we can grab from the loader function. Now, we can do pretty much anything inside the loader function, but the typical use case is for us to fetch our application data from the server using an API and return the result to our component. Whatever we return inside the loader function is accessible inside the component. Just for demonstration, we can return a simple object here, and let's go to our user details component and we'll learn how to get the data returned by the loader. To do that, we'll need to use a hook function called useLoaderData. And now if we console log out the loader data variable, and let's go back to our browser, we can see that it is printing out the exact object that we return inside the loader function. How cool is that? We could also return a HTTP response object inside the loader function. And behind the scene, React Router will automatically convert the response into a JavaScript object to our component. In fact, React Router does provide us a helper function called JSON that will convert any object into a new response object. And if we hover on a function, we can see in the documentation, it is returning us the response type as the end result. Now, if we go back to our browser, we could still see that the user detail component was able to grab the data correctly. Alright, it is a good place to stop here. We will continue in the next lesson. Key takeaways for this lesson. The loader function will be triggered when a page is mounted in a DOM. We can only use the loader function only if we're using the data API. In other words, creating the router using the create browser router function. We could return anything inside the loader function, and if we decided to return an HTTP response instance, React Router will convert it into a JavaScript object automatically. That's it for now, and I'll see you again in the next video. In contrast to loader, action is a function that will be triggered whenever a page sends out a non-GET HTTP request. In other words, we'll most likely trigger it whenever the user submits a form. And now let's see how we can get started with the action function. Similar to loader, we can define the action function inside the route object. And just like its sibling, it will also take in an argument that contains two properties, the parameter and the request object. Parameter is referring to the dynamic parameter inside the URL, and the request is the outgoing HTTP request. We'll console log out both the parameters and the request inside the function body just for demonstration. And now let's see how we can trigger the action function. Let's go to our user details component and let's build a form so we can have form submission to trigger the action function. Now we can't use the native HTML form because it doesn't work nicely with React Router. What we should do instead is to use a form component provided by the React Router library, and this API is very similar to the native HTML form. We'll provide an action prop and also a method prop. And within the form, we'll create an input field and give it a name of email. And we'll give it a little bit of styling so that it's not that ugly. Alright, let's go to our browser and give this a go. I'll enter some random things inside the text input and hit enter, and we can see that in the console logs that we entered earlier has appeared, and they're logging the parameter and the request of this form submission. Now what we would write inside the action function is really up to us. Typically, we would write the corresponding functions to send the API request to the server. And to do that, we often need to read the body of the request. And React Router makes it simple for us. We just need to read the form data method from the request object inside the action function. The form data method returns us a promise, so it might be better for us to use await here. And we'll also console out the form data just for demonstration. And now if we go back to the browser, upon submitting the form, we can see the form data printed out in the console. Now this form data is a native form data object where we can't read the content directly. If you want to read the payload of the form data, what we can do here instead is to convert it into an object by using the object from entries method provided by JavaScript natively. Let's try again. And now we can see the content inside our form data. The key is the name of the input and the value is whatever I have just entered inside the text field. Isn't that neat? Alright, let's move on. Similar to loader, we can return whatever we want inside the action function. Typically speaking, we will return the result of the API request. Let's quickly mock up some response here. And let's say the API returns us an object that contains an error saying that the email that we just entered has an invalid format and is wrong. Now the UI will need to receive this message and display it to the user. To get the result of an action, we need to call another hook called UseActionData. Let's console log out the action data just for demonstration, and we'll go back to the browser. At the very beginning, when the component was first mounted, the action data is undefined because the action function hasn't been run yet. Now if we submit the form, we can now see that action data has now got a value, and the value is exactly what we have returned inside the action function. And now we can go ahead and show this message inside our UI. Let's do that. We will put the error message directly underneath our input field. So the idea here is that we will write a short circuit that checks if the error field is presented inside the action data. We are using the question mark optional chaining operator here to check if action data is undefined or not, so that our code doesn't break. So if the error field is presented inside the object, then we will load a span that shows the error message. Alright, let's go back to the browser and run this bad boy. And now the moment when I submit the form, the error message shows up, which is exactly what we expected. Okay, so that was a quick overview on how the action function works in React Router. We will continue to dive deeper into the other features provided by the React Router in the next lesson. I'll see you there. Key takeaways for this lesson. Action is triggered when a component submitted a non-get HTTP request. Just like the loader function, the action function receives the URL parameter and the outgoing HTTP request instance in its argument. We can receive the result of the action function through the UseActionData hook. This is particularly useful when we want to display the error message from the API or the success response from the API result. That's it for now, and I'll see you again in the next video. Sometimes we need a way to manually run our loader and action function programmatically. As we stand now, there's no way for us to run the loader and action function manually. The loader is triggered whenever the component was mounted to the DOM, while the action is triggered when we submit the form. Now there's a good number of reasons why we might want to programmatically trigger these two functions. For example, if we want to refetch data from the API server, we need to rerun the loader function. Or when we want to perform some sort of custom validation in a form, we might want to trigger the action function manually after we have checked all the user input inside the form. Now, in order for us to run the loader and action function programmatically, we will need to use a new hook called useFetcher. In short, the useFetcher hook will return us a fetcher object that provided us a handy API to work with the loader and the action. Let's see how this thing works. To get started, we first need to call the useFetcher hook. Now to programmatically call the loader function, we can use the load method provided by the fetcher object. And just for demonstration, I'll chuck a UseEffect here and manually call the load function after 2 seconds. Now when we call the load method from the fetcher object, we gotta pass in an argument. And the argument is the URL of the route. In our case, we wish to call the loader function of the user details page. Therefore, we simply need to chuck in the URL of the user details page inside the load function. A takeaway here is that you can technically call any loader function in your app by using the fetcher load method. You just need to pass in the correct URL. Now, it is very common that we need to call the loader function of the current route. And if you're like me, where I have got a very bad memory, when I don't even remember what I had for breakfast today, I'll be honest with you, I can't remember what the current route is. To make our life better and lazier, what we can do here is we can call the useLocation hook to grab the location object. And from the location object, we can read the path name property to get the current route. That way, we can simply call the load function dynamically, and even if in the future, if we change the URL, our page would still work. And just for demonstration, I'll console log out some message inside our loader function, and we'll give this bad boy a run. We'll head to our browser, and upon clicking on the refresh button, take a look at the console. When the component was mounted, we see ABC gets printed out for the first time, and after 2 seconds, the loader function gets triggered again, and therefore we see another ABC. Again, we're seeing 2 ABCs in the second console log because we are currently having strict mode turned on. So far, so good. Let's move on. We will see how to programmatically run the action function in our code. To do that, we'll call the submit method on our fetcher object. The first argument is the payload of this submit request. Whatever you put inside here will become the body of the request. You can also put in an HTML form element here if you wish. We will set it to null at the time being. Now the second argument is the important one. It is an object for us to configure the method and the action of the submit request. So we can specify our method to be post here, and the action is the URL of the submit request, so we can just use location.pathname. If you want to call a different action function, simply supply the corresponding URL inside the action option. Next, I'll modify the action function so it's more obvious in our browser console log. Alright, let's give this a go. We'll go to our browser, refresh the page, and as you can see here, our component did send out an action request. However, if you look at the form data inside our request, it's empty at the moment because we have set null as the first argument inside the submit function. Let's fix that. I'll put in some dummy value as the body, and let's see what happens next. Back to our browser, hit refresh, and now we see hey you inside the form data. Isn't that simple? Alright, let's move on. So the fetcher object does provide us some other properties that we can use over the life cycle of a submit request. For example, we can read the state of the fetcher by reading the state property on the fetcher object. The state is a string that can either be one of these three: idle, submitting, or loading. The state is idle when nothing is being fetched. It is submitting when the form is sending out the request, and it is loading when the loader is being called. The form data property is the form data inside the payload of the submission request. Form action is the target URL of the form submission, and form method is the corresponding method. The data property is the return result of either the action or the loader function, depending on which one is calling in the life cycle. And lastly, form enc type is the encoding type of the submission. It could be JSON or form data. And now let's go to the browser and look at how this console log will turn out inside the console. Okay, now you can see that initially all the fields are undefined because there was no form submission when the component was first mounted, and the state is idle initially. However, after 2 seconds, the state becomes submitting, and we can see that there's something popping up for each of the property. The form data is a form data object where we need to unpack it to see the data inside it using object.fromEntries. We'll do that shortly just for demonstration. And we can see the URL of the submitting target and also the method, but the data is undefined because the data property represents the data returned by the action function, which is not resolved yet. And if we go further down inside the console log history, towards the end, once everything is settled, the state changed back into idle, and the form data, form action, form method, and etc. became undefined again. However, this time, the data property is now showing the result of the action function. And that is exactly what we are expecting. And now let's go back to our code and try to unpack the form data so we can see that inside our console log. As discussed previously, in order for us to convert form data into object, we simply need to call the object.fromEntries function, and that should just work. However, we do have an issue here. The form data property could be undefined, and if we put undefined inside the fromEntries function, JavaScript will not be happy about it. So what we should do here is to give this fromEntries a fallback. The form data is undefined, then we'll give it a fallback of an empty new form data object, and that should do the job. Let's go back to our browser. And as you can see inside the console, we're able to see the content of the form data object now. And one last thing before we end the lesson, the fetcher object actually provided us another property called form, and it is a non-navigating substitute for the default form component provided by React Router. The default behavior of the form component is that React Router will redirect us to the action URL once we have submitted the form. If we don't want this default behavior, then we can use the fetcher form component instead. Alright, that's basically everything that we need to know about the fetcher API. We'll go deeper into the React Router in the next lesson. Alright, key takeaways for this lesson. The useFetcher hook returns us a fetcher object that contains a powerful API to programmatically trigger the loader and action function of a particular route. The load function on a fetcher object will trigger the loader, while the submit function will trigger the action. The form property inside the fetcher object is a non-navigating version of the default form element provided by React Router. The state property can either be idle, submitting, or loading. This is useful to render the loading UI of a particular component. That's it for now, and I'll see you again in the next video. Revalidation is a concept where the loader function of a route gets re-triggered when we submit the form. By default, React Router will re-trigger the loader function, in other words, revalidate the component under a few conditions. And if we look at the documentation here, this few dot points simply outlines the condition where the component will be revalidated. Essentially, when the action function is called after a form submission or when a URL is changed. If you find this confusing, don't worry. Let's look at revalidation in action. No pun intended. Now we're inside the user details page, and currently this route has a loader. And as I mentioned earlier, as we submit a form, React Router will revalidate the route, in other words, call the loader function. So that means when we call the submit function on the fetcher object, it will trigger the revalidation and therefore running the loader function. Let's go to the browser and test our theory. I'll refresh the page. Initially, the loader function runs when a route was loaded. However, after 2 seconds, we run the submit method on the fetcher object and therefore triggering revalidation, and we can see our console log is printing out loader loading once again. While revalidation is triggered by React Router automatically behind the scene, sometimes we do need the power to trigger it manually. And to do that, we need to call another hook called useRevalidator. Let me show you how it works. First of all, we will call the useRevalidator hook to create a revalidator object. And we'll go ahead and call the revalidate function from the revalidator object inside our setTimeout. So in theory, if we go back to the browser now, we should see our loader function get called after 2 seconds, as you can see inside our browser's console log here. Calling the revalidate function is exactly the same as we call the load function on the fetcher object against the current route. It is pretty rare that we need to call the revalidate function, but this feature is here if you ever need it. The main purpose is to get the page to reload all the data, so we will have the latest data in the UI. Now there are instances where we only want to revalidate under a certain condition. If you want to define a condition on when to revalidate the page, we can simply define a should revalidate property inside the route object. Let's go back to the main JSX file and we will add a new property called should revalidate, which is a function, and the function will set an argument that contains all sorts of information that might be useful for us. I'll console log it out for us to see what's inside it. And this function should return us a boolean. That determines whether we should revalidate the current route or not. I will return false for now, and let's see what will happen. And remember, we're triggering the revalidate function inside our user details page after 2 seconds upon the page is rendered. And we're returning false inside the should revalidate function. So in theory, our loader function will not be triggered for a second time after 2 seconds. Alright, let's refresh our page. And after 2 seconds, we only see the args argument gets printed out inside the console, and the loader function was not triggered because the should revalidate function is returning false. And now let's take a look at what's inside the argument of the should revalidate function. It is an object that contains the URL information and also the return result of the action function of the current route, which is nice. And that means we can control whether to recall the loader function depending on what the action function is returning us. If the action function has failed, we might not want to call the loader function in the current route. I would suggest you to take a quick look at the documentation to find out more about the revalidator. Alright, key takeaways for this lesson. Revalidation is the notion of retriggering the loader function of the current route to get a fresh dataset for the current page. Upon submitting or changing the current route's URL parameter, React Router will automatically revalidate the route. We can manually revalidate the route by calling the revalidate function on the revalidator object. That's it for now, and I'll see you again in the next lesson. As our app grows larger and larger, it is unavoidable that we're going to have a lot of routes. Having a good way to organize these routes in our React project can really help us to go a long way. You don't really want to manage 1,000 lines inside the main JSX file, do you? Let me show you a quick technique on how I organize my routes in my React project. On the fundamental level, the route object are basically JavaScript object, and they're living inside an array. So technically speaking, we could have splitted this array into groups and combined them all together back inside the correct browser router function. I will show you what I mean. So currently in our sample app here, we have a few routes which are what we consider as public pages. So I can create a new array here and I'll call it public routes, and I'll put those routes inside this array. And we also got an admin routes. Again, I'll create another array and put the admin routes into this array. Now back inside our correct browser router function, we can now unpack those routes into the array. Isn't that neat? So now our correct browser router function is very clean and easy to understand. The next step is to move this routes array into their own file and import them inside this main.jsx file, so we can keep our main.jsx file as clean as possible. Let's create a new folder called routes inside our source directory, and we'll go ahead and create 2 files in there for our admin routes and public routes. Once we're done, we'll move all the corresponding routes logic into these 2 files, and also export the route array in each of these files. Once we're done, we just need to import them back inside our main.jsx file. And that's it. Let's go to our browser and test our app and see if it is still working. Whoops, we've got an error. It says failed to resolve import. This is because we have changed our folder structure and the import routes that we copy over is no longer referencing the correct file. Let's fix that. Currently, our routes file is living inside the routes folder. And that means in order for us to access the pages folder, we need to go back up a level. And that should fix the issue. We will do the same for our public routes. And now let's head back to the browser and see what will happen. And we're greeted by a blank screen. Oh shit. Now upon inspecting the browser console, we see that we've got an error. It says that the angle bracket is an unexpected token. Seems like we have some issues with the JSX syntax. Let's go back to our code and fix this. It turns out that when we try to import our public and admin routes on line 6 and 7 here, JavaScript is already trying to parse the JSX syntax inside the file. The thing is, we can't really use JSX in anywhere that we like. We can only use JSX syntax inside the React component or React-related functions. So how do we fix this? The answer is simple. we simply need to render the component without using the JSX syntactic sugar. In other words, we need to call the underlying React function behind the JSX syntax, which is simply react.createElement. Let's go ahead and refactor the routes inside the admin routes file. Once we're done, we'll go back to the browser and our app is showing once again. Beautiful. After all these hustles, the end result is us having a very clean main JSX file, where we delegate all the routes logic into their own files. Now let's say our app grows larger and larger and the routes number in each of these routes files become too big. You could do the same thing again and split them up into another file. This file structure is extremely flexible and I hope it can help you to organize your massive project. Alright, key takeaways for this lesson. As our app grows, it is a good idea to split the routes array into multiple files. We can only use JSX syntax in the React components or directly in the argument of React functions. To create React components in other places, we should call the createElement function directly. That's it for now, and I'll see you again in the next one. It is certain that our app will throw an error at some point in time. It could be the user tried to visit a non-existing page, or the user tried to visit a restricted page without the appropriate permission. Now, in those kind of scenarios, it's only proper that we will create a custom error page to display the error to the user. Thankfully, React Router provided us an easy way to handle this situation, and it is something called the error element. Let's look at how it works. So let's just say we're throwing an error in our home component. Now, the default behavior of React for any errors is that it'll bubble the error up, and if no one's catching the error, then it'll render the default error message in our browser. So if we go to our browser, you can see that the default error page is not that pretty, and it's even giving us a suggestion to create our own custom element. Now in our route definition, we can actually add a new property called error element, and the value will be a custom React component, which will be rendered whenever there's an error. Let's go ahead and create an error element now. And we'll import our newly created error element back inside our public route.js file. And now if we go back to our browser, instead of seeing the default error page, we're now seeing our own custom error element. Isn't that great? However, we're not done yet. What if we want to show the actual error message in this custom element, which in our case will be hey ya, that was thrown inside the home component. Now React Router again has made it easy for us. To do that, we simply need to call a hook called UseRouteError. The hook will return us the error instance that was thrown, and for us to easily display the error message, we simply need to read the message property in the error instance. Alright, let's take a look at the browser, and now we see hey ya in the second line. So that was a quick overview on how we can make our own custom error page. However, our error page at the moment is very plain and simple. Let's spice things up a little bit with our awesome CSS skill. Alright, let's take a look at the result. Looking good. So now whenever you have up, you will be seeing this beautiful error page. One last thing before we end the lesson. It's very typical for us to provide a button to redirect the user back to their original location whenever an error happens. Let's quickly correct that button. We can make use of the link component provided by React Router DOM to send the user back. In the toProp, we simply need to provide a value of -1, and that will do the job for us. And let's also quickly style the buttons. And we'll test it out in the browser. Since the home page is the one that will throw the error, we'll first go to the contact page and visit the home page. And now if we click on the button, we're back to the contact page. Isn't that great? Alright, we'll continue in the next lesson. Key takeaways for this lesson. We can define a custom error element by providing an error element property inside the route object. We can send a user back to the previous location by passing the -1 to the toProps in the link component. Alright, that's it for now, and I'll see you again in the next video. GitHub Pages is a static site hosting provider. And as we mentioned in the previous video, routing in a single page application is not as straightforward as it seems if we want to deploy our application to GitHub Pages. So as a workaround, the first step is to change browser router into hash router. So we'll call the correct hash router function rather than the correct browser router function in our main JSX file. If you want to know the reason, please review the previous episode. The link is in the description. After we have shifted to hash router, let's take a look at the URL, and you'll notice that there's a hash symbol before the URI, and that means we're now using the hash router. Once this is done, we're now ready to deploy our app to GitHub Pages. Now we can't just deploy our source code to GitHub Pages because the GitHub Pages server is unable to serve the React source code. What we should do instead is to build and compile our code into a format that GitHub Pages is able to serve. Let's write a script for that. I'll create a new bash script here. If you're using Windows, you might want to install Git bash to run this script. For Mac and Linux user, you should be able to run this script as it is. The first step that we want to do here is to terminate the script whenever there's an exception. We can do so by using the set-e command. Next, we'll need to run the build command to build our application. We're going to cd into the build directory, and then we'll create a new Git repository inside the build directory and push the content to our GitHub Pages branch in our GitHub repository. Let's quickly write the code. We will cd into the build folder and initialize a brand new Git repository and stage all the content inside the build folder and do a commit. Then we'll push everything to our GitHub remote repository. cd- will return us back to the folder where we were before. And now we'll make the script executable by adding the execute permission to our script. And let's run our script. Oh dear, we've got an error. Seems like the build directory is called dist rather than build. Let's change it into dist and we'll try again. Okay, seems like it's working. Now if we head to our repository, we should be able to see a new branch in the branch list. And now go to settings and click on the pages option panel on the left hand side. Make sure that you have selected deploy from a branch option here in the source drop down here and select GitHub Pages in the branch section down here. After that, click on the save button and wait for a few minutes. GitHub Pages should cook you something after that. Once that's done, you can click on the deployed link to visit your application. Now, oh shit, we're greeted by a blank page. And upon inspecting on the developer tools, the issue is our static asset is using an absolute path rather than a relative path. If you look at the URL of our website, the URL actually contains our repository name as the URI base. So we should add this behavior in our Vite configuration. Let's go back to our VS Code. We can simply get Vite to use a relative path by adding a base property inside the configuration. And the value will be /. Let's rerun our deploy script. And go back to our GitHub Pages and wait for a few minutes for GitHub to cook our application. After it is done, we'll go back to our application and refresh. And now we are greeted by our amazing app. And if I click on the links in the navbar, it's giving me the correct pages without any dramas. Oh good. And that's it. It is that easy to deploy our app to GitHub Pages. We will continue in the next lesson. I'll see you there. Sass is awesome, and it is super easy to start using it in a React project. The first thing that we want to do is to install the Sass package using npm. So we will go to our terminal and type in npm install Sass. Once we have done this, the rest of it is basically the same as working with normal CSS. It is just a matter of changing the file extension .css into .scss or .sass. And just for demonstration, I'll quickly create a new CSS file called home.module.scss to provide styling for our homepage. I'll quickly write some Sass code and import the Sass file back inside our component. Let's console log out the imported CSS and see what will happen in the browser. And as you can see, it works exactly just like its normal CSS counterpart. the imported object exposes all the classes that we define inside our module CSS file, and we're free to use these classes anywhere inside the component. I'll create a div with the container class, and inside it we'll have a h1 with the title class. And now if we go back to the browser, we can clearly see that our h1 here is now loading the Sass styles. And that's it. That's how you can enjoy using Sass in React. Alright, key takeaways for this lesson. To use Sass in React, simply npm install Sass. And everything else should just work the same way as vanilla CSS. That's it for now, and I'll see you again in the next video. Most of the time, a prop of a component is meant to be a specific data type. However, it is possible for us to pass in any arbitrary data type to a component, and that would break our code. Let me show you what I mean. Now suppose we have a price component, and the price component will simply display a number value in a proper pricing format. We will assume that this component will take in a prop value which has a type of a number, and within the component will round the number up to 2 decimal points by calling the toFix function on a number type. Now that means if we pass anything other than a number as the value prop, then this component will break. Let's give it a shot. I'm going to load the price component in our home page and pass in an array to the value prop. And now if we go to the browser and visit our page, our app will just tell us that we have fucked up as expected, because we're calling the toFix function on an array. Now, wouldn't it be better if we've got a way to restrict the props data type that we can pass to a component? And thankfully, React does have a solution for us. And it is something called the props type. Essentially, prop types is a special object that defines the data type of the props in a component. Now, to define the prop type of a component, we need to inject a property prop type into the component function. So let's refactor our price component for a bit. Now once we have set the prop types property, the next thing that we want to do is to define all the props that this component will have inside this object. Currently we only got one, which is the value, and the type of it should be a number. Now we can't really use the native JavaScript number type. We have to import it from a special library called prop types, which is part of the React ecosystem. First of all, let's install the library using npm. And once we're done, we'll import the library in our price component and get a number type from the library and set it as the type of our value prop. And that is basically it. And now if we head back to our home component, and if we hover on the value prop, we can actually see a type hint now suggesting that this prop should be a number. And if we go back to our application in the browser console, we can actually see that React is giving us an error saying that value cannot be an array, it must be a number. And that means the prop type is working. It is performing validation for us. So by defining prop types for a component, we are not only doing validation, we are also writing documentation for our component to specify what props would our components accept. There are a whole range of different validator provided by React out of the box. Feel free to check out the documentation if you're interested. The link is in the description. Alright, key takeaways for this lesson. Prop types allow us to specify the data type of our component's prop. It serves as a validator and documents our components at the same time. That's it for now, and I'll see you again in the next lesson. Now that we have learned about the basic of React, let's start building the component for our application. Let's start by building the buttons in our app. And just a quick recap, here are the buttons that we need to build. So we have the blue round button, and also a button with an outline, and the icon button. And now I'll go to VS Code and get right into it. First of all, let's grab all the dummy components that we have created before. And we'll start with the round button. We'll create a new button folder where we will put all the button components inside here. And we'll go ahead and create another folder called round button and create a new round button JSX file. and we will use the RFCP shortcut to generate the component with prop type. The round button component is basically a wrapper around the native button element. So we'll simply pass the prop to the button element, and we'll focus on writing the CSS next. We'll go ahead and create a new module Sass file and quickly create a new round button class and import it back inside our round button component. Let's see if this works in our browser. We will load our round button component in our homepage just for testing purposes. Next, let's go to our browser, and we can see that the round button component appears in the DOM. Great! And now we can start styling this round button. First of all, if we want to make a button round, we need to set the border radius to 50%. The button is a little bit elongated now, but that's okay. It's because we haven't set the width and height yet. Let's do that. We will set the width and height to 100 pixels, and now you can see that the button looks a lot better now. Next, let's make the content of the button a lot more readable by changing the color into white. And we'll add a little bit of shadow and also give the left and right side a little bit of breathing space. Our button looks a lot better now. However, it doesn't feel like a button just yet. When we hover on a button, I think giving the button a little bit of depressed effect will make it nicer. Let's do that. Let's add a new hover pseudo class to our class round button here, and I'll set the background color to be a little bit darker and also decrease the blurriness of the shadow. And that looks a lot better than before. Alright, let's move on. We will create the outline button next. Now let's do something different this time. Instead of using a CSS file to style this component, we'll try to use Windy CSS built-in classes. First of all, let's give a little bit of spacing around the button, and then we'll style the font and give the button a border and some hover and focus effect. And that's it. With Windy CSS, it is possible for us to style our component without a CSS file. However, as you can see here in the code, sometimes it could get quite messy, as we will have a very bloated class attribute for the element. Which one should we use? Well, it's really up to your personal preference. For me, I actually prefer to use a CSS file rather than using Windy CSS directly on my button. I only use Windy CSS for general helper classes like margin and padding. Alright, let's move on to the last button type. We'll create an icon button next. We will repeat the same procedure, creating the component file and load it inside the home page. Now with icon, it's better for us to install a third-party library and wrap it around with our button icon component here. There's a fantastic library called Material Design Icon, and we're gonna use that in this project. We'll go to the terminal and install Material Design Icon Font, JS, and React. Once we're done, let me show you how this library works. First of all, we'll need to go to the Material Design Icon official website, and from here, we can browse for all the icons that are provided by Material Design Icon. Once you have found the icon that you want, copy the name, and back to our code, we will import the icon from the library that we just installed. So the first step is to load the icon component provided by MDI React. This icon component is a wrapper to ensure that material icon will work properly in the DOM. Next, we'll import the icon from the MDI.js library. The icon name has to be camel cased in contrast to what we have just copied. Once we have imported the icon, we simply need to provide it to the path props in the icon component. And there you go, it's now working. The icon component allows us to customize the color and also the size of the icon by simply passing in the size and color prop. To make our button icon component more flexible, we should define the color and size props and give them a default value. Now currently we're hard coding the icon. Ideally, we should make it into a prop as well. And refactor our home component to make it pass the account badge icon to our button icon component. And finally, we'll add some windy CSS classes to make our icon button look like a button. Alright, looking good. Those are basically the buttons that we need in this timer app for now. Building these components might look a little bit daunting in the first glance, but it's actually not too bad once we started doing it. I hope it was not too scary for you. We will continue to build more components in the next lesson. I'll see you there. Let's build the toggle or the switch next. Now the toggle is a little bit trickier than the other components. However, behind the scene is really just a checkbox that is either giving us a true or false value. First of all, let's set up the file structure. I'll create a new toggle component. Its module CSS file. And load the component in our home page. As I mentioned just now, a toggle is simply a checkbox under the hood. Let's create a checkbox for now. We will need a label and also an input element with a type of checkbox. Now the label requires a unique ID, and we can't really just write a hard-coded ID here because we're going to reuse this toggle component over and over again in our app. So we need a way to uniquely generate an ID. Thankfully, React has just got a tool for us, and it is a hook called useID. So basically, this hook function will always generate a unique ID for us that we can use anywhere that we like. In this case, we'll put it as the ID of our checkbox. And now if we take a look at the DOM, we can see that our input element is assigned to a unique ID string. Now I would like to insert some content to our toggle component. Let's define the props for our toggle component. We'll destructure the children, and we'll define a value prop, which will be a boolean. If it is true, that means the toggle is on, and false when the toggle is off. And we'll put the children inside a spam element within a label, and also bind the value to the check attribute of our input element. So now if we go back to the home page and assign true to the value prop, you can see that in the browser, our checkbox is now ticked. Let's quickly put a value prop inside our prop types and pass the remaining props into the input element. And we'll create a dummy reactive variable back in the home component to handle the checked status of the checkbox. Since we're passing all the props into the input element, that means we can start to listen the change event. And when the checkbox is changed, we want to set the checked state into the input's checked attribute. Alright, now we've got a working checkbox, we can finally have some fun time styling the component. And just a heads up, if CSS is not your forte, the CSS code might look a little bit scary, but I'll try my best to explain what's going on. Now, as a lazy developer, I didn't really want to write this component from scratch. Especially there are so many amazing UI libraries out there that can do a better job than me writing the component from scratch. So instead of reinventing the wheel, I simply go to Google to look for something to copy, to inspire myself. Since there are a lot more Tailwind CSS resources out there online compared to Windy CSS, so I'll search for an inspiration based on Tailwind CSS. And then I found this amazing website that has exactly the component that I had in my head. What a coincidence! So I have decided to not copy, but to take this inspiration and make it into our own. Now we gotta understand and break down the code before we can make it into our own. First of all, notice that there's a class called SROnly, which stands for screen reader only, and that will make the element not visible unless the user is using a screen reader. And that means the appearance of our toggle is controlled by the div followed right after the input element. And the span is just showing the label of the toggle. Now, first of all, let's copy the classes on the label element onto our label. It will apply inline flags and make the position into relative and center the items vertically and changing the cursor appearance into pointer to make this toggle looks like it is clickable. Let's also quickly copy the span classes, which will basically give a little bit of breathing space onto the left side and format the text and also the color. The dark prefix will simply specify what would this text looks like when we are in dark mode. Alright, and now let's make the switch. So the switch or toggle really contains two parts, the background and also the round circle that can be moved left or right. Let's create the switch background first. We will create a div and add some classes to create an oval with a gray background. This will form the base of our switch. Now the next step is to make this background turn blue when we turn on the toggle and revert it back to gray when we turn off the toggle. We can make use of some Windy CSS pseudoclasses modifier to achieve this. So we'll go to the input element and target the next sibling of the input element, which is the div, by using the sibling modifier. And we're saying that when we checked on this input element, we want to apply a blue background to the sibling. And that's it. So now when I tick or untick the box, the div will alternate between a gray or blue background. And that was the base of our switch. Let's create a round circle on the switch now. To do that, we'll need to use pseudo elements, and I will recommend to do it using an external CSS file, rather than relying on the Windy CSS classes. Otherwise, our code would turn into an abomination very quickly. In fact, if you take a look at the code that we just copied, it is actually pretty ugly. As you can see, it is quite long, and I don't think any sane human being would enjoy reading that. Anyway, let's write the pseudo element for the switch button in our toggle module CSS file. We will create a new class called toggle and reference it inside our div element. Okay, so our main objective here is to add an after pseudo element, which is a round circle that floats on top of our toggle base. We'll give it a position of absolute and give it a border and also a width and height and make it round. And now you see that the circle is not aligned properly on top of the base. It is because we have yet to hide the checkbox. Let's do it quickly by adding the SROnly class onto the input element. And now it looks a lot better than before. We just need to add the animation to move the white circle left and right whenever the switch is clicked. To do that, we'll go to our toggle module CSS file. What we want to do here is to move the white circle to the right when the switch is turned on, and that means we can add a checked pseudo class on the input element. So let's create a new class called input, and when the input is checked, we will target the after pseudo element of the toggle, and we will set the transform property so we can move the white circle 100% in the X direction while everything else can remain the same. And now back inside our toggle component, we simply need to add the input class to our input element. Once we are done, if we click on the switch now, you can see that the white circle is actually moving left and right. Beautiful. Let's add the animation for the translation. We can do so quite easily with CSS transition. We will apply the transition based on all the CSS properties and will make the duration to be 0.15 seconds and the timing function can be set to ease. And if I click on the switch now, you can see a smooth transition between the left and right side. And that is basically it. That to me is a beautiful switch component that I'm more than happy to reuse over and over again across my app. However, if we look at the original code, they do have some sort of rings on the component when we click on the switch. To me, this is not necessary as I'm quite happy with our component already. However, you can add in those CSS classes if you want. Alright, that's it for now, and we'll continue to build our app in the next video. I'll see you then. We will work on the editable input next. And just a quick recap, here's how it works. When we click on a text, we will turn on the edit mode, where we can go ahead and edit the text. And when we click away, it will go back to normal. And if we hover on the text, there's a little pencil icon where we can click on it to toggle the edit mode again. And if we edit the text and click away, the text will be saved. It looks simple, but there's actually quite a few things going on here. Alright, let's dive in right away. Let's first set out the basic structure by creating the element and also load it back inside our homepage. And now in a component, we will have a div wrapper that wraps around a span element that holds the text followed by the edit button when we hover on this text. And now we'll add some CSS to the wrapper and also create a class called wrapper inside the module CSS file. We will also create an input class for the span element. We basically need two modes here in this component, the edit mode and the non-editing mode. Under the non-editing mode, we want to show the text as it is, while under the editing mode, we want to show a text input inside the span element. So that means inside the span, we basically need to put in an input element and we'll assume the value of it to be some props passed to this component. And we want this input element to be read-only when we are in the editing mode. Let's create a state for the editing mode. So we'll create a state called isEditMode and set the default value to false and pass this state to the read-only attribute. So this input element will be read-only when we are not editing. And also setting the data type for the value prop in the prop types. Alright, let's go to our browser to test our code. And I have f***ed up because I forgot to import the useState function. Let's quickly fix it. And now the error is gone. We'll go back to our home page and add a value to our editable input component. Alright, it seems like it's working. If we click on the input field, we were unable to edit the text at the moment. However, if I change the isEditMode state to true, we were able to see the edit cursor inside the text field now. Beautiful. It would be cool if we turn on the edit mode whenever we click on the text. Let's do that. We'll add a new onClick event listener and I'll call the function turn on edit mode, which will simply set the isEditMode state into true. So now whenever we click on the text, we will enter the edit mode. Alright, let's add the pencil icon next. The pencil icon is kinda hovering on top of the input field. We could achieve this easily by setting it into an absolute position. Let's make use of the icon button component that we have created in the previous episode. Next, let's style this icon so that it'll only show when we are hovering on the text. I would like to pass some classes to the button icon component, but if I do it directly, I'll end up overriding the internal classes that I use in the component itself. So what I'll do is to merge the class name prop with the internal default classes. We'll first give the button a little bit of background color when we hover on it, and we'll define a new class inside our module CSS file so that we only show the button when we hover on the wrapper. And we'll add the button CSS to our button icon component, and now if you look at the browser, the button will only show when we hover on the text. Great! But now I think the button is too far away from the input field. Let's make the button to have an absolute position and place it on the right edge of the wrapper. We'll give the wrapper a fixed width so we can control how long the content should be. Next, we'll add an event listener to the button icon so that whenever we click on it, we will turn on the edit mode. And in theory, we should also make the button disappear while the edit mode is turned on. So let's short circuit this button. So we'll only show this button when the edit mode is off. So now when we click on a pencil icon, it will disappear. But now it leads to another problem. After clicking on a pencil icon, we should autofocus on the input field so the user will know that they can start editing the text. Let's implement an autofocus logic. Now to do that, one of the easiest way is to create an React element reference by using the useRef hook. Now a React reference is an object that represents any value that we would like to mutate, and that includes a DOM element. You can think of it as some sort of fancy way to wrap around a data. The useRef hook function would accept a default value for the ref object, and what we want to do here is to set our input element as the ref object. So to do that, we can pass in a special ref attribute and load the input ref object. This will set the input DOM element as the subject of the reference object. Once we have set up the input reference, to focus on the input field, we first need to obtain the subject of the reference, which we can do so by reading the current property. So the current property represents the input element, and now we just need to call the focus function and it should just work. Beautiful. Now we gotta solve one last problem. When we click away from the input, we should set the edit mode back to false. This is fairly easy to do. We simply need to add an onBlur event listener to the input element, which will set the isEditMode state property back to false. And that is basically it. That is a working editable input. And now I'll do a little bit of polishing by relaying the props to the correct places. And that's it. We'll continue in the next lesson. I'll see you there. Let's build the progress bar. Now the progress bar might look complicated, but it is actually quite straightforward. First of all, let's set up the file structure. We'll create a new component file and load it back inside the home page. Next, we'll define a prop called %, which is basically the percentage of the progress bar, and it should be a number. Now, when we look at a progress bar, you can basically split it up into two parts. The first part is an outer container that provides the background, and the second part is an inner container that represents the progress. Let me show you what I mean. We'll first build the outer container. So let's give the outer div a full width and a gray background, a rounded edge, and a little bit of height. And now, as you can see, we've got a gray bar in the browser. And now, let's build the inner container. We'll have an inner div with a blue background, the height same as the outer container, a rounded edge, and the secret of the progress bar is basically the width property that we're gonna assign to this div. Just for demonstration purposes, I'll set the width to be 60% for now. Whoops, we got a typo on the background color, and that's why the progress bar is not showing in the browser. And now we've got a working progress bar. And if I change the width to be 40%, the progress bar will be filled up 40% as well. And that means we should pass in our %prop as the width property. And I'll give the %prop a default value of 100. And let's assign a value to the %prop in the home component And seems like our progress bar is working. Beautiful. And that is basically it. We now got a functional progress bar. Alright, we'll continue to build more components in the next few videos. I'll see you there. Tooltip is a very useful component when we are building our application. So this is how I envisioned the tooltip component to work. We can wrap any element with the tooltip component, and when we hover on the inner component, then the tooltip should show. So let's quickly scaffold the component. And inside the component, we'll define a few props. The first prop is a tooltip, which is the text that we want to show to the user when the user hover on the element. And then we'll relay the children and the rest of the prop to a span element. And now we'll create a new data attribute on the span element where we'll pass the tooltip prop onto it. Now the purpose of this data attribute is that so we can utilize this data from the CSS. Let's create a CSS module file and I'll show you what I mean. So the idea of the tooltip is that we're going to make use of the after pseudo element to show the tooltip. First of all, we'll give the tooltip class a relative position so that we can easily style the after pseudo element. Next, we'll add the after pseudo element and the content would be the data tooltip attribute. Let's quickly pass some data to the tooltip prop so we can experiment with the CSS. Once we're done, we'll give our pseudo element an absolute position and give it a little bit of width, the left and top positional properties, a background color, a white text color, and some padding to the left and right. We will also style the font size and the border radius. And now what we want to do is to only show the tooltip when we hover on the main text. Let's do that. First, we'll set the opacity to 0 on the tooltip itself and only set the opacity back to 1 when we are hovering on the main text. Let's try it out. Great, it is working. However, it feels a little bit clunky. It will be better if we add a little bit of animation for the tooltip to fade in and out. And the easiest way to do this is to use CSS transition. The transition property will be the opacity property and the duration will be 0.25 seconds. Let's try again. And now it looks a lot better than before. And that's how we can build a simple tooltip component that can be wrapped around any elements that you like. We will stop here and continue in the next lesson. I'll see you there. Let's build the countdown timer next. If we look at the timer as a whole, it basically consists of a few components: the progress bar, the buttons, and also the title. From the previous lessons, we have already built the building blocks to construct this timer component, and I will consider this timer component as a container. So let's create a new directory in our container folder and I'll call it timer, and we'll create a new component called basetimer.jsx. Now let's talk about the API of this timer component. On the high level, we need to define how long would a timer last. So we'll need to define a timeout prop, which is basically the duration of the timer. We also need to provide the user the flexibility to do something when a timer is completed or when a timer is stopped or started. And that means we should expect the user to pass in these three functions in a prop. Next, we'll also have an autoplay prop, which will be a boolean, and when set to true, the timer should run automatically by itself. And last but not least, we should have a title. Now the first thing that we want to do in a component is to set up a clock. And that means we need to create a reactive variable which represents the total time remaining. And for each passing second, we'll decrease this number by 1. So let's create a new state called total time, and I'll give it an initial value which is equal to our timeout prop. Next, we'll create a function to start the timer. The start timer function is basically a wrapper around the setInterval function. So what we got to do here is to decrease the total time state by 1 for every passing second. And that means within the setInterval function, we will call the setTotalTimeSetter function and we'll pass a callback function to it to handle the setting logic. So the first step is to calculate the time remaining by subtracting total time by 1. If the time remaining is less than or equal to 0, then we should stop the timer. We could call the clearInterval function to clear the timer, however, we need a timer ID. Let's create a new variable in the outer scope here to store the timer ID of our setInterval. So back to our if statement, now we can simply pass the timer ID into the clearInterval function to stop the timer, and we'll return 0 if the time remaining is less than 0. Otherwise, we'll return the time remaining as the new total time state. And that is pretty much our start timer function. Next, when a component was first mounted and if autoplay is set to true, we should automatically call the start timer function. Let's create a UseEffect for that. So the UseEffect will simply check if the autoplay is true. If yes, then we will run the function. Now the timer can be paused or stopped by the user when the corresponding button is clicked. Let's create a few more functions to pause, resume, or stop the timer. We will also create 2 more states to handle the state of the timer, which are the pause state and the started state. And I'll set them to false by default. And now, to pause the timer, we'll simply set the isPausing state to true, and also stopping the interval timer. On the other hand, resuming the timer means to set the isPausing state back to false and calling the start timer function again. Stopping the timer means that we'll reset the total time back to the initial timeout prop and also set the has started state into false. And last but not least, we'll clear the timer. And we should also set the has started state into true in the start timer function. Once we've got all these helper functions, we can now start to build our user interface. I'll create a function to render the buttons, and based on the state of the timer, we will show different buttons accordingly. So when the timer is not started, we would like to show the play button, and when the timer has started, we want to show the pause and stop buttons, and when it is paused, then we want to show the play and stop button. We can easily handle these conditions by using some if statements. Let me turn on my 10x speed hack to quickly write the scaffold of our code. We will be using our round button custom component here that we created in a previous episode. And we'll call this render buttons functions in the return statement of this component. Let's quickly load it inside our home component and we will view our button in the browser. Whoops, we got an error. Seems like I forgot to import the UseEffect hook function. And now once we have fixed it, we're able to see our start button in the browser. Let's quickly implement the logic to change the state of the timer. In theory, when we click on the start button, the timer should start. But before we attach any event listener to our round buttons, we should give our base timer a timeout prop. I'll give it 10 seconds for now, and back inside our base timer component, we will start attaching the event listener to each of the round buttons. Clicking on the start button now, we'll start the timer, and the pause and stop buttons would show up. If I click on the pause button, then the play button will show, and if I click on the stop button, the whole cycle should reset. And when I click on the start button again, I should see the pause and stop button all over again. And it seems like I have made a mistake. When we stop the timer, we should also reset the pause status. And when we click on the play button, we should resume the timer rather than starting the timer. Let's try clicking on the buttons again. It works a lot better. Next, we'll display the remaining time in a countdown clock and a progress bar. Let's start with the progress bar. This should be quite straightforward. We just need to load our progress bar component that we created in a previous lesson and put in the appropriate percentage. We need to find a way to express the remaining time in terms of percentage. Let's create a helper function for that. To get a percentage, we can simply divide the time remaining, which is the total time, by timeout, and multiply the result by 100 to express it in percentage. And then we'll code the function in the %prop of the progress bar component. And if we click on the start button now, we can see that the progress bar is working. Great! Our next task is to show the remaining time in a countdown clock. And the countdown clock will show the time in a format of minute, and second. Let's create a component for that. I'll create a new component in the same folder and I'll call it countdown clock. And we'll let this component to accept a prop called time remaining, which is in seconds. And within the component, we'll calculate the minutes remaining and also the seconds remaining from the time remaining prop. And in the HTML, we'll return an H1 where we'll show the time in a format of minute, seconds, as mentioned before. Now we're padding our minutes and seconds so that we are always getting 2 digits. Let's also quickly style our H1 and we'll load it back inside our base timer component. Let's click on the start button and our timer is now counting down along with the progress bar. Beautiful. And now let's quickly use some magic to style our base timer component. And lastly, we should run the onStop, onStart, and onFinish functions in the appropriate places. And that is basically it. Our base timer container is now completed. I think that's a good time to stop here. We'll continue in the next lesson. As our application grows larger and larger, there will be a need for our components in the app to share data with each other. The notion of state management is to have a central location to store all the state or data in our application so that any component can easily access the data from this central location anytime and anywhere that they like. There's no need for us to do something what we call as prop drilling, which means to pass the data from one component to its child and to its grandchild, so on and so forth. For example, suppose we have 4 components here and we have a state called user that we declared in component 1. Now, component 4 requires this user state to work properly. Traditionally, to achieve this, we will need to pass this user state as a prop to component 2, component 3, and finally component 4. While this will not cause an issue, however, component 2 and 3 are not direct consumers of this user state. And that makes it a little bit shitty because we got to write extra code in component 2 and 3 to pass this data to component 4. How do we make it better then? Well, we can use state management. So we will create a central location and create our user state there and just get component 4 to read from the central store. That's it, problem solved. Now, while the notion of state management is fairly simple, however, the implementation might be a little bit complicated. Generally speaking, there are a few options for us to use state management in the React ecosystem. The first and the oldest solution is a library called Redux. It is a third-party library that has been used by big enterprises since the early days of React. The thing is, Redux is quite complicated and it might be intimidating for beginners. So after the success of Redux, the React team worked on a native solution to implement a state management system using React Hook out of the box. and it is something called the Context API so that the React user doesn't need to rely on the third-party solution like Redux anymore. In the next few lessons, we'll explore the Context API and apply it to our timer app. I'll see you there. Key takeaways for this lesson. State management is the notion of having a central location to store all the components' state. It eliminates the need of prod drilling and it makes it easier for components to share data. React supports state management natively through the Context API. That's it for now, and I'll see you again in the next video. The first thing that we want to do to set up the Context API is to create a context. But what is a context, you may ask? Well, a context is like a container that holds our global state data. Let me show you how it works. First of all, let's create a new folder in our project and I'll call it store. Now this store folder will contain all the code that we'll need for the state management. And just for demonstration, I'll create a new file here and I'll call it global store. And within this file, we need to create a context. To create a context, we need to call the create context function provided by the React library. As mentioned just now, this is the container that will hold all the data in our global store. Once we're done, let me show you how to load data into this global store now. First of all, let's quickly export the global context and we'll go to our main JSX file to register the global store. Let's import the context. Now the context object exposes a few properties that is needed for us to register the global store. And I'm talking about the provider property in particular. The provider property is actually a React component where we should wrap it around our app components in order for the Context API to work. Now the provider component accepts a prop called value, and this is where we can pass in the initial value of our data in the store. Let's create a dummy object for now. And we'll pass this object to the value prop. We can read this state in any component that was wrapped underneath the provider component. Let's try it out. We'll go to our home page, and to read the data inside the global store, we will need to call another hook function called useContext. And the hook function will accept one argument, which is the context object instance. Let's console out the result of this function and we'll see what will show up in our browser console. Oh dear, we see an error. Seems like there's an import issue in our global store. Let's fix it by using ES6 imports rather than a require function from common.js. And now back to our browser, we can now see the global store object containing the data that we passed to the provider. Beautiful. Isn't that neat? We can now read the data in our global store by simply using the useContext hook function. However, I'm not too happy with the current API at the moment. To read the data from the global store, we currently need to import the hook function and also the context object. Let's make a small improvement on this procedure. Why don't we delegate this logic into our global store? We'll go back to our global store file and we'll create a helper function called useGlobalContext, and we'll return the result of useContext right here. And that means back inside our home page, in order for us to get a global store, we can now replace the code here with just one function code. And that will make our life a lot easier. We'll go back to our browser, and we can still see the global store printed out in the console as before. Great! But now if we look back at our main JSX file, as our app grows larger, the content inside our store will get larger as well. And the main JSX file will not be the best place for us to define the content of our store. And the code here looks a little bit messy as well. Let's migrate them to our global store file just like what we did before. We will create a React component, and this component will be a simple wrapper around the provider property from the global context. And then we'll relay all the props onto the underlying provider component. Once we're done, back inside the main JSX file, we can now simply load our global provider component to replace what we had before. Let's test our code. We'll go back to our browser. There wasn't any error, and we can still see the global store object in the console. And that is the basic on how we can set up state management using the context API, and how to read the data from the store. We haven't learned about how to mutate or change the data in the store yet, and we'll talk more about it in the next lesson. I'll see you then. Key takeaways for this lesson. A context object is a container that holds data. The provider property in a context object is a React component that is required to wrap around our app components for the context API to work. If we do not use the provider property, then the context API will simply refuse to work. The useContext hook function allows us to read data from the store. That's it for now, and I'll see you again in the next video. A reducer is a function to mutate the state or data in the store. Because of its unintuitive name, a lot of people doesn't know what the it means when they first saw the term. Let's create a reducer now and look at the syntax. So a reducer is essentially a function with a very specific signature. The first argument is the state that's currently inside the store, and the second argument is something what we call an action payload, which is basically the data that we will pass in when we trigger the reducer later. We will come back to this action argument in just a bit. It is easier to explain it when we see it in action. For now, we'll console log out both of the arguments just for demonstration. Now a reducer function has a very specific trait. That is, whatever we return in this function will override the entire state in the store. And that's how a reducer can modify the state in the store. For now, we will return the state as it is, and we will export this reducer function. Once we have defined a reducer, we need to register it. And to do that, we can use another hook function called useReducer. The hook function will set the reducer as its first argument and the initial state as its second argument, which in our case will be our state variable. Now the useReducer hook will return us an array. The first element of the return array is the reactive version of the state, similar to what would have happened to the data passed to the useState hook function. Now the second element in a return array is what we call a dispatcher function. The dispatcher function is a function to trigger the reducer registered by this hook. And the first argument that we pass to the dispatcher function will become the action argument inside the reducer. Let me show you what I mean. But before we do that, let's refactor our code here, because I don't think we need to declare our state variable up there anymore. We can simply pass it directly to our useReducer hook function. And now we will also modify the value prop in our provider component. So we're passing in the reactive state and also the dispatcher function. This will allow us to access the dispatcher function in any component in our app. The dispatch function will trigger the reducer, and the state is a representation of all the data in the store. And that means we can read or modify our global state anywhere that we like in our app. Let's try to call the dispatch function. We'll go to our home page and we'll run our dispatch function in the onClick event listener of this button. Just for demonstration, I'll call the dispatch function with an argument of some silly string. Remember, this argument will become the action of the reducer. And remember, our reducer at the moment does nothing but merely console logging the state and the action argument. Let's go to the browser and see what will happen. Whoops, we got an error. Seems like I have broken the rule of the hooks, because I'm calling the useReducer hook function in a global scope. Let's move it inside the global provider component. And seems like that fixes the issue. And now to trigger our reducer, we simply need to click on this little button here. And as you can see in the console, we are seeing the state and the action argument from the reducer. The action is ABC, which is exactly what we pass to the dispatch function, and state is the data in our store. Now passing a string as the action of the reducer doesn't seem to be very helpful, since we can literally pass anything to the dispatcher function. A more useful data structure would be an object. Typically, we would pass an object that contains two properties, a type property that defines the operation type, which in our case here, we wanted to update the only field in our store, which is the hey key. And the second property is the payload, which is whatever data that is associated to our operation. In this context would be the new value of the hey key. So ideally, after running the dispatch function, we would like to see ice cream inside our global store. Let's refactor our reducer so it will work as expected. Now we're assuming the action is an object that contains two properties, the type and the payload. And type could be a variety of different strings. And we need to handle each string on a case-by-case basis. The easiest way to achieve this is to use a switch statement. Currently, we only got one case, which is update hey. And the logic is to update the hey property. So what I'm going to do is to return a new object that contains everything in the current state, but I'm overriding the hey property, and the value will be equal to action.payload. For the default case of the switch statement, we'll simply return the state as it is. And now let's go back to the browser and we'll open up the developer tool and we'll click on our global provider component. And now notice that currently we have hey made. The moment when I click on the button, it changes to hey ice cream. Isn't that great? This is basically how a reducer works. And again, its purpose is to update the data in the store. Alright, before we end the lesson, let's quickly make some improvement on our code. Since the reducer operation is fixed, let's create a constant for that. And we'll reference it both inside the reducer and also when we call the dispatch function in the home page. The benefit of having this action object is that it makes refactoring a lot easier in the future if we ever need to do so. Alright, key takeaways for this lesson. Reducer is a function that mutates a state in our state management store. We can register a reducer using the UseReducerHook function. We use the dispatcher function returned by the UseReducerHook to trigger the reducer. That's it for now, and I'll see you again in the next video. Consumer is yet another way to read data from the state management store. Similar to provider, it is a property from the context object, and it is also a React component. Let me show you how it works. First of all, let's go to our home page, and what I'm going to do here is to import our global context object and call the consumer property on it to create a component inside our DOM. Now the consumer component has a very specific trait. That is, we can only put a function within the component as its child. And the function should accept one argument, which represents the data in the store. And the function should return HTML elements that will be rendered inside the DOM. And just for demonstration, I'll simply return a simple div and I'll read the hey property from the state. And just a quick recap, currently in our store, we have two properties, the state and the dispatcher function, and within the state, we only got one hey property. Now let's go to the browser, and now we can see that we've got a mate in the DOM. Beautiful. So consumer is basically an alternative syntax for us to read the data from our store. Now you might be wondering, how can a consumer be useful? Well, to a retail store manager, a difficult consumer like a Karen could be a nightmare. However, to a React store, a consumer could be used to conveniently render components that have no business logic and are tightly coupled to the data in the store. For example, in our app, we might want to have a user avatar icon that we want to use over and over again across multiple places, just like the avatar icon in the Google homepage. Now this component will contain some user information of the current logged-in user, like the name and the image URL. But the component itself does not contain any business logic. The purpose is just to render the user's avatar. And now this scenario will be a perfect use case for a consumer to shine. And we could wrap the consumer in a normal React component, so we can easily use it across our app. Let me show you a quick example. Let's quickly create a new component called HeyMate. And I'll move the consumer code that I had before to this component. So this HeyMate is really just a wrapper around what we have done already. And now, back inside the home component, rather than writing all this mess, we can totally simplify it to this HeyMate component. And back to our browser, we can still see our mate inside the DOM. Okay, so again, consumer is only useful when a component is tightly coupled to a data inside the store. It is just another way for you to read the data from the store. Alright, key takeaways for this lesson. Consumer is an alternative way to read data from the store. Consumer is a React component, and it can only accept a function as its child. The function should return a DOM node. Consumer is best to use as a DOM component that is tightly coupled with the state in the store. That's it for now, and I'll see you again in the next video. Okay, we'll put everything together and build a dashboard. Here's what we're going to build. We can divide this page into 3 parts. The first part is a timer header, followed by a plus button, and when we click on this button, we'll add a new timer card in the middle. The second part is the timer cards. We can remove or edit the cards as we wish. Lastly, we have the start button and also a switch to indicate whether we want to loop the timers indefinitely. Alright, let's get into business right away. First of all, we'll create a new page component called timer, and we'll add a new route for this page in our public routes.js file. Now we'll go back to our timer page component, and just like what we mentioned before, we have 3 sections here: the header, the cards, and the start button. And I'll wrap everything in our public layout component. And now for the headers, I'll quickly add the h1 tag with a plus button wrapped around our tooltip component. Let's check it out in our browser, and it is looking great. And now let's work on a card section in the middle. Essentially, we are rendering an array of timer objects for this card section. So the first step is to create the state management store to put our timer objects. We'll create a new file called timer store, and inside it we'll create a new object that contains a property called timer, and this is where we'll store our timers array. Now each timer would have an ID, title, and duration. I'm just hard-coding the properties for now, just for testing purposes. In the real world, the ID should really be unique. We could achieve this by generating a UUID from the UUID package. Let's quickly install it. And we'll call the v4 function to generate the UUID for our timers. And then we'll export the timer store object and import it back inside our global store JSX file. We'll get rid of our dummy data that we created in the previous episode and put in a new property called timer, and this is where we'll put in everything related to our timer store. And we'll load our timer store state into this object. Having this structure is great because in the future, if we've got other store, we can simply add more to our provider while keeping them organized. Alright, now we'll create a new component called timer list where we'll render all the timer cards. Now in this component, we'll get all the timer objects from the store, and for each of the object, we'll render a card. Since the main purpose of this component is to merely render something, and it doesn't have any business logic, so this is the perfect place for us to use a consumer. So we'll use consumer from the global context and retrieve all the timers from our timer store. And now we're going to convert each of the timer into a card. Let's create a new component for that, and we'll call it timer list item, and we'll load it back inside our timer list component. And back inside our timer page, we will load our timer list component to make sure everything is working fine. Looking good. And now let's build a skeleton of our timer list item component. We will create a square and within a square we basically have two elements. The first block is the input and the second block is the delete icon. For the input, we have an editable input for the title and another one for the duration. We'll go ahead and style the elements for a bit so they are displayed properly inside our DOM. Alright, we'll leave the business logic for now. Let's create the third section, which is a start button and the toggle. We can use the button outline and the toggle component that we created previously for these two elements. Alright, now that we have done with the scaffolding, let's add the business logic. We will start with the plus button beside our timer header. So when we click on this button, we are expecting a new timer card to appear in this dashboard. And that means we need to add a new object to the timer array in our store, which means we need to introduce a reducer to mutate the state inside the store. Let's add a reducer to our timer store. And just a quick recap, a reducer would take in the store state as its first argument and the action payload as its second argument. We will use the switch statement to handle the operation types and will define a series of possible actions inside a constant variable. So when the action type is equal to setTimer, we'll simply mutate our timer store state and then we'll export our actions and our reducer function so we can register them back inside our global store. Let's refactor our code for a bit. We will call the useReducer hook function to register our timer reducer. And pass the return state and dispatcher function into the provider. And now we've got access to the dispatcher function, we should be able to add more items into the timer array in the store. We'll go back to our timer page and add an event listener to the plus icon. We will call it addTimer, and within the event listener, we need to trigger the dispatch function from the timer store. Let's import our timer store by calling the useGlobalContext function, and we'll also extract out our timer state for easy access. And now within our addTimer function, we simply need to call the dispatch function from our timer store and pass in the action payload. For the action type, it will be setTimers, and the payload is an array of all the existing timers plus a new timer object. And now, in theory, when we click on the plus button now, a new card should pop out inside the DOM. There you go. It is working beautifully. We are now able to add a timer. We should also implement the ability to delete a timer by clicking on the rubbish bin icon. We'll go to our timer list item component and add the event listener to the delete button. We'll call the event listener remove item. And what we're going to do inside this function is to find the index of the current timer object inside our timer store and remove it from the array. First of all, let's import our timer store. And in order for us to get the index, let's quickly create a helper function to compute the current timer index. Next, we'll remove the timer object by calling the dispatcher function and again the setTimer action to reset the whole timer array so that we're not including the current timer object in this component. Alright, let's give it a go. We will click on the delete button and the card is removed. We'll add more timer and they can all be deleted. This looks pretty good. However, we still have a lot more to do. For example, editing the timer title and the duration. I think it's a good place to stop for now, and we'll continue in the next lesson. Okay, now let's implement the logic so that we can edit the text within our timer cards. First of all, let's create an event listener on the title input field. We'll call it update title. And what we're going to do inside this event listener is to first get the state from the store. In other words, finding the particular timer object from our store, and then we'll update the title field inside it. And finally, save it back inside the store. So to get our timer state from the store, we can simply make use of our helper function, getItemIndex from the previous episode, and we can create a new updated timer object by unpacking the previous timer object and overriding the title field. For the new value, we can simply grab it from our event target property. And now we need to call the dispatcher function to override our target inside the store. Again, we can make use of the existing setTimers action, and the payload will be all the timers object before our target index plus our updated timer, and finally everything after our target index. Alright, let's give it a go. I'll go ahead and edit the first timer object, and as you can see, we can edit the title without any issue. Let's add another timer. Edit the title. Looking good. And now let's verify the state inside our React developer tool. Within a global provider, we can see that our states are indeed updated in the store. So far, so good. Let's do the same for the duration field as well. Similar as before, we need to create an event listener and attach to our editable input element. And now the code will be very similar to what we have done already inside the update title event listener, so we just need to copy and paste, right? Well, hold on a sec. Copy and pasting is a big red flag. Technically speaking, the only thing that we need to do differently this time is the field name. So instead of title, what we wanted is the duration field, and the rest of the function is basically the same. So the big question now here is, can we do better without copy and pasting? Well, you know the drill. The answer is yes. We are going to use some magic to work around this. There are a few ways to solve this issue, but here I'm going to apply some functional technique to solve this problem. Now the idea is to create a higher order function that returns an event listener function. Let me show you how it works. We will create another function called updateTimer, and it will accept an attribute argument. Now this attribute argument will be our field name. In other words, either title or duration. And as we mentioned before, this is a higher order function that will return the actual event listener. So we will return a function here, and the logic inside this function is basically the same as what we have done before in the update title function. We will copy and paste the existing logic, but this time, rather than hard coding the field, we will make it dynamic by referring to the attribute argument. And now look at this. We've got a function that will create the event listener. And that means we can refactor our existing code by throwing our existing event listener into the bin, because we can now create our event listener by calling our update timer function. We just need to change the attribute argument and everything should work fine. Let's test our code. I'll change the title and durations and verify it in the React developer tool. And everything seems to be working fine. Beautiful. And I just noticed that our timer cards are not aligning properly. Let's fix that by applying some classes in the timer list component. Let's flex some magic. And that should do the job. Okay, let's move on. We will work on the logic for the toggle now, so every time when we toggle on the loop indefinitely switch here, we should update the state in a store. And that means we need to add a new data inside our store. Let's go to our timer store, and we'll add a new field called isInfinite inside the state object. And we'll give it a default value of true. And now back inside our timer component, we will simply read the isInfinite state from our store bind the value of the toggle, and also create a new event listener for our toggle component. So inside this onToggle event listener, what we want to do is to update the isInfinite state. Currently, our reducer cannot handle this operation. Let's go to our reducer and implement this logic. It is the same kind of rule. Let's add a new action. And in the switch case, we'll simply override the value of the isInfinite state, where we'll get a new value from the payload property in the action. Alright, let's go back to our timer component. And now inside the onToggle event listener, we simply need to call the dispatcher function. The type will be our newly created action, which is setIsInfinite, and the payload would come from the event target and a check property. That comes from the underlying checkbox HTML element. Alright, let's test our code. If we click on the toggle, it seems to be working, and if we look at the developer tool, our isInfinite state is indeed changing. Beautiful. Alright, I think it's a good place to stop here. In the next lesson, we will implement the logic on what will happen after we click on the start button. I will see you there. Okay, now the next thing we want to build is the logic to run our timer. And just a quick demonstration again, when we click on the start button, we'll go into a new page that has a countdown clock, which is based on what we have defined in the dashboard. We can pause the timer, or resume the timer, or stop the timer. Alright, without further ado, let's dive into the code. Okay, first thing first, let's create the timer page. I'll go ahead and create a new folder in our pages directory called timer, and also a start component inside it. Next, we will register this component inside our public routes.js and add another route to render the start page. Now notice that I'm keeping my files and folder structure the same as our routes path. This will keep our files and folders organized and help us to easily maintain and debug our code. Alright, next, we will go to our timer dashboard and modify the start button so that we're redirected to the start page when we click on it. We can do so by wrapping the button around with a link component. Alright, let's test our code. We will go to our browser. If I click on the start button, we are redirected to the start page, where at the moment there's nothing in it. So far, so good. Okay, let's go to our start page now and we'll build the component. First thing first, let's load our layout, and we know that this page has mainly two components, a preview and also the base timer. We have created the base timer component in a previous episode, but we haven't done anything with the preview component. Let's quickly build it now. We will create a new file inside our timer folder, and I'll call it previewtimer.jsx. And we'll load the component inside our start page. And now this component is really just a dumb component that will show two information. First, the upcoming timer object's title, and second, the upcoming timer's duration. Since we're showing the timer's information, we'll get this component to take in a timer prop, which is basically the timer object. And now just for demonstration, we'll quickly pass a timer prop to this component inside our start page. So we'll load our first timer object from our timer store and pass it to the preview timer component. And now let's open our browser and start building the preview timer component. So for the timer title, we'll create an h1 element. We will increase the size, give it a gray color, and also reduce the opacity to 80%. And now I would like to show the up next label before the title. So let's create a span element, which has a smaller size compared to the actual title. For the duration, we'll have a p tag, and we'll give it a gray color, opacity, and also a smaller font size compared to the title. Alright, looking good. We'll also give the whole component a little bit of padding and margin bottom. to maintain social distancing from the elements around it so it won't get COVID-19. Okay, let's go back to our timer page, and the next thing we want to do is to put in the countdown clock. In the previous episode, we have already built a base timer component, so let's just add it in here. And just a quick recap, the base timer component accepts a few props. We will put in the timeout and the title property, and just for testing purposes, I'll be using the first timer in our store, just to render the component correctly. We should also pass the onStart, onFinish, and onStop hook function so it can do something whenever this event happens. So basically, when a countdown has expired, we want to move on to the next timer object. So that means in the onFinish hook, we need to change the current timer into the next timer that was listed inside the preview timer component. And this means that we need to have a way to keep track of our current timer index so we know that which timer to run next. And within the onFinish hook, when there's no timer left, then we should stop the countdown clock. A way to keep track of the timer index is to create a new state in our timer store where I'll set the default value to be 0. And now back inside our start page, we can easily get our current timer by using the current timer index. We will quickly refactor our DOM so that we're using the current timer object rather than hardcoding to be the first item in our timers array. And now in the onFinish hook, for us to move on to the next timer, we simply need to add the current timer index state in our store by 1. And to do that, we need to define a new action in our reducer and add a new case inside the timer reducer function. And now back to our start page. To move the current timer to the next timer, we simply need to call our new action by using our dispatcher function, and the payload will be the current timer index plus 1. However, we're not done yet. We still need to handle the situation where the current timer is the last timer in the array. So that means we need a mechanism here to check whether we are at the end of the array or not. It is pretty simple. We just need to check if the current timer index is equal to the total timer length minus 1. And we should only move on to the next timer when we are not at the end. Now when we have arrived in the last position in a timer array, we gotta do another check here. That is to check whether the user has turned on the isInfinite option. If yes, then we want to reset the current index to 0 and repeat the whole cycle again. If not, we also want to reset the current index back to 0 because the user might manually click on the start button in the dashboard, and we also do want to put a stop to the loop. Now, one of the ways to control the loop is to have a local state here, and I'll call it hasStopped. This hasStop state will control whether we want to stop the whole timer cycle and to redirect the user back to the home page or not. So back inside our onFinish function, we will run a check. If the user did not want the timer indefinitely, then we want to set hasStop to true. And since we're going to reset the index back to 0 anyway, so we can simply call the dispatcher function at the very end, and I'll set the payload to 0 this time. And now let's go down and refactor the DOM based on our hasStopped state. We only want to show the preview timer and the base timer when hasState is false. If the timer is stopped already, then we want to show a message telling the user that we are done and have a link to redirect the user back to the dashboard. Let's test our code. And oh dear, we've got an error. It says that we cannot update the global store while we're re-rendering the base timer. This is likely because we're trying to do two things at once. There are mainly two issues here. Now the onFinish function was actually triggered by the base timer component. And within the onFinish function, we are trying to update the current index of the timer in the global store, which then will affect the DOM. So the problem is our onFinish function has yet to complete and we are already rendering a new base timer component. This is not acceptable and therefore React is complaining about it. How can we resolve this? Well, we could delegate the onFinish function's logic into the event loop in JavaScript by using the setTimeout function. So now the onFinish function is actually running in the event loop rather than by the base timer component. What that means is we can now safely run our onFinish function without worrying about the DOM node. Now the second issue is React may not render our base timer component correctly because we did not provide it a key. So based on our logic, whenever we change the current timer index, we want to have a new base timer component, and we need React to re-render that part of the DOM for us. To make sure React does the job for us properly, we should provide our base timer component a key prop. So this is saying whenever the current timer index state has changed, then we want to re-render our base timer component. Okay, now let's test our code for one more time. We will go back to the dashboard, click on the start button, and it is now all working without a single complaint. Beautiful. Let's also quickly style our components while we're here. We will just center the item in the middle of the page. Okay, looking good. Now there are still a few other issues that we need to address before we end the lesson. First of all, our preview timer is currently not okay. The timer that we insert into our preview timer is the current timer. That is not correct. Let's create a new helper function and I'll call it nextTimer. So this helper function will simply resolve the next timer for us. Within the function, we gotta run a check to determine whether we are at the last item or not. If we are, then we should return the first timer when the isInfinite option is turned on. Otherwise, we'll just return now. If we are not at the last item, then we'll simply move on to the next timer. Once we're done, we can simply create a new variable called preview timer to load the next timer and pass this variable to our preview timer component. And just for the sake of testing, I am going to add a new timer in our timer store. And now, as you can see, we are now seeing the correct preview timer. And let's quickly click on the start button to test our code. Once the countdown expires, we are seeing rest instead of workout now. Beautiful. The thing is, the countdown clock does not trigger automatically by itself. Let's fix that. We simply need to pass the autoplay option into our base timer component. Okay, now let's go back to the dashboard and we'll click on the start button. However, we've got a weird issue here. You can see that the countdown clock isn't working just right. Now the reason is because we currently have strict mode turned on in our React app, and our base timer has a UseEffect that triggers the timer automatically when the component is mounted, and strict mode will trigger it twice. Therefore, the setInterval function that was used behind the scene was called for 2 times, and hence our timer was decremented by 2 seconds for every second passed. To resolve this, we simply need to turn off strict mode back inside our main.jsx file. Alright. And now the issue is gone. However, when we click on the stop button, we do want to show the all done message. We'll go back to our start page. When the onStopHook function is called, we simply need to set the hasStop state to true and reset the current index back to 0. Let's test our code. So now, if we click on the stop button, we are greeted by the all done message, and if we click on the back button, we're back to the dashboard. And one last thing before we end the lesson, in the onStart function, we should set the hasStop state to false, even though technically we're not using this onStart function, but there's no harm for us to leave it there. Also, there's a chance that our preview timer could be now, so we should do a check before we render the preview timer component. Alright, that's it. That's basically our timer app. We still have one more element to incorporate into our timer app, which are the sound effect when the countdown expires or when transition into a new timer. We'll continue in the next lesson. So we want to play some sound when the current timer is transitioned to the next one, or when the whole timer cycle is ended. To achieve this, we can use the audio API provided by the browser out of the box. I have previously found these two sound effects to use in our app. You can find some other sound effect that suits your taste. I promise I will not judge you. Anyway, here are the sounds that we're going to use in our example here. So first of all, this sound will play when the timer is transitioned to the next timer. On the other hand, this will play when the all done message is showing in the app. To get started with the audio API, we first need to load our MP3 file into our start page. And just like loading CSS file, Vite can also handle MP3 file by using the ES6 import statement. This is the recommended way to load static assets in our app project. We can just let Vite to do all the hard work for us. Anyway, once we have imported the MP3 files, we can create a new audio instance by instantiating the audio class. The audio constructor will simply take in the path to our MP3 file, which is basically our imports. So now once we got our audio instance, we will play our transition notification whenever our timer is finished. However, if we have reached the end and we're not in the infinite mode, we want to play the alarm instead. So we'll pause the transition notification and call the play function on the alarm instance. When a user stops the timer manually, we should also call the pause function on both the alarm and transition notification. Okay, let's test our code now. We'll go to the browser. I don't think my screen recorder can record the sound, so you gotta trust me on this one. We'll click on the start button. When the timer expires, ooh, I can hear the sound now. And if you look at the browser tab, you can see a little circle just beside the title, and that is the evidence. Alright, that concludes our timer app for this series. I hope you enjoyed everything so far. We will be talking about some advanced React concept and JavaScript in part 2 of this React Deep Dive series, which will be built on top of this timer app. Alright, have a good one, and I'll see you in the next video. If you would like to see more content, consider supporting us by becoming a member at my website, Acadea.io. It is similar to Patreon, but in return, you get a lot of premium tutorials and lessons. If you can't become a member, that's totally fine. We are just happy that you are here. We spend a lot of time and energy to produce high-quality videos for you. Feel free to check out our other videos on YouTube, and if you can leave a thumbs up, you will really make my day. If you subscribe, I would jump for joy, and I'll make more videos for you. Thanks for your support, and I'll see you next time.